welcome. I think we are online. Refresh this now.
Yeah, we might have a little bit of stream delay here. Let's see.
I think we should be.
Yeah, it should be online pretty soon.
Yeah, we on our end have a bit of a stream today. I'm just going to assume we started the stream. Well, hello and welcome to the TUM hangar at Oberpfaffenhofen. We at the WARR Move are now running our last preparations for our Move Up launch, the very first one of those. And in the coming year, there's going to be a bunch more of those and more to come. And yeah, oh, we're live. Okay,
that's good.
What's going to happen today? Basically, we're going to launch a stratospheric balloon, and we're just going to tell you some things about the student club and how to join it in the coming semester, as well as some information about the technologies that we develop, and yeah, just have a good time and in this pretty special place. Hi, Iggy. Well, as you can see, if you look in the stream, you see Ferdi's beautiful face right in the stream. And yeah, if you look like the golden thing that the two people are working on there, like above the rightmost cone, that's
can we
the gondola.
zoom in a bit?
I think we can. I like the view that we have.
I mean, but I would zoom in.
I mean, yeah, try to zoom in, I guess. Oh, I can't. That's the max. Okay. We can't. Yeah, so basically the golden pixel there is our gondola.
And you can see we are still working on it, preparing it for the launch today, which should happen in around 1 hour at 12.
Yeah. So yeah, the launch window today is between 12 and the 14. We aim to launch at 12 since this is the most favorable conditions for us. And yeah, now the area that you see that is surrounded by the tape and the cones is going to be the area where we fill up the balloon. Once the balloon is filled up with helium, we're going to take it outside of the hangar to launch it. The reason for that being is it's at this point in time a bit windy. At the time when we launch it, the wind should have calmed down a little bit. Well, in the meantime, while people prepare for the launch, we have prepared some information for you guys about Move and the projects that we work on. So let me just open that up for you. Ja.
Kannst du das nochmal neu laden? Nee, ich glaube, es ist der letzte.
Nee, ich hab's gerade online.
Okay, perfekt.
Well then, yeah, just go for it.
So as you have heard by now, we are Move. Move is part of the Wissenschaftliche Arbeitsgemeinschaft für Raketentechnik und Raumfahrt, so the Scientific Work Group for Rocketry and Spaceflight, which is a student club here at TUM that is focused on space-related projects.
The stream volume is quite low at the moment.
Quite low?
Okay.
Yeah.
Kann jemand die Hangartür zumachen? Das windet immer rein. Und das ist immer ein bisschen laut. Nee, mach die da. Mach beide. Wir brauchen die Hangartür, glaube ich, gerade nicht offen.
So.
Lass die offen am besten, weil da ist das Handy dran. Sorry.
That's fine. WARR is like the general umbrella organization that has a couple of different teams that build different things. So we have a team that builds rockets, we have a team that builds satellites, that's us, that's Move. And we also have a team that builds microgravity experiments and one that builds rovers. So to give you a bit more general idea about what Move actually is, so we are a student club that builds satellites, and today we are also building a balloon to test satellite components. We have more than 100 active student members here from TUM and other Munich universities, and we are quite an interdisciplinary team, so we have people from all kinds of different studies. So we have our electrical guys still working on the gondola, and aerospace students, computer science. So
ja, Standbild und Resis abgeschnitten. Okay, danke.
Thank you for pointing that out.
Wir haben wirklich ein Standbild tatsächlich.
Ein Programm?
Nicht mal ein schönes
Standbild. Das ist doch von dir, oder?
Maybe, ja.
Nein, das ist wirklich.
Such mal die Error Message.
Ja.
We should have it stand already.
I mean, the camera is you can
Ja, ich hab's ja gerade Stream Delay. Ich hab's gerade eben gefixt.
Okay, let's
Yeah, you can see me fixing it right now.
This is okay. We
Das
can.
ist Stream Delay. Das
Okay. So
Ja, wir warten mal kurz, bis wir wirklich wissen, dass wir die Präsentation. I mean, we're just gonna wait a little bit till we see the presentation again. And we don't have to do the. Wir könnten auch einfach durchscrollen, das ist einfacher.
yeah, maybe. Let's see.
Okay, ja.
Ja, ich will mal schauen.
Ach,
Das ist ein altes Video. Das ist delayed.
Das ist it's delayed. Yes.
Okay, dann machen wir einfach weiter.
Full screen.
Nein, was wir jetzt gerade sagen hören, das heißt, wir können jetzt einfach weitermachen.
Yes, but it's cropped a bit weirdly.
Also ist es immer noch cropped?
Maybe it's because of the full screen mode. Let's see.
Muss mich sehen. Ja, ich bin. I'm a bit of a dum-dum.
Okay, but just in general, let's talk about Move. What is Move? What have we done so far? And what do we want to do in the future? So Move is again a student club that is that builds satellites and of course also our balloon missions for testing these components. And it has all started with the first Move satellite, which was launched in 2013, which is still in orbit, but we are no longer actively talking to it. We have in 2018 launched Move 2, which is another satellite. It was used for technology demonstration for certain solar panels. It is still in orbit and we are still talking to it. So we have a mission control team that handles overpasses. So when the satellite flies over Garching, they essentially talk to it and get out the science data that we want to collect for it. And it has been in orbit since 2018, so it's quite a cool mission and still going strong. We also have Move 2B, which is essentially a clone of the Move 2 satellite that has been launched in 2019, and it has been deorbited in 2023, at the end of 2023. So right now we have one satellite in orbit that we are actively talking to, and we of course want to do more satellites to teach students how to build satellites. So this is really a student-led organization where we try to build satellites. We want to learn from how to do it better and in general advance, for example, certain hardware that we develop ourselves and then test it in orbit to make sure that it actually works in space. What's really cool about Move is that you can also actually join us. So, so for example, I joined 1.5 years ago with basically no experience on how to build satellites. All I knew was essentially, hey, I'm really interested in space. And so what's really cool about Move is that we have this hands-on education for students. So you don't just build a satellite in theory, you don't just design it in theory, you actually go through and launch it, which is quite unique.
Yeah.
It's really cool.
For me, for example, like I started studying aerospace a year ago, and I'm taking part in my first launch campaign as the second, now third semester technically student, which is honestly a really unique thing, and I just love it. There's no other place that you can do things like that. Let's go. Ja, Alex.
Bei der Flagge sieht man wohl.
Ja, ich hab's schon verschoben.
Perfekt. Okay.
Alex Burg is the former recovery guy that I have taken this place over. Greetings back to Norway. Yeah.
Tim, we're not gonna do that.
Yeah.
Okay, so what's really cool about Move is that we just handle everything related to satellites. So it's not just about designing and building the satellite, but also testing it out, having a team that, for example, does our balloon campaigns. So we have two Jacobs who were really instrumental in making this happen, and I'm sure we will see a really cool launch today in around 50 minutes. And so it's really about organizing everything. It's about making the software, making sure the finance and sponsoring works. We need marketing, we need public relations, we need people who organize the general organization. So if you want to join us, you can always do that by going to warr.de/kickoff. I think it's for students of Munich universities.
Yeah, so LMU is fine. And
LMU as well.
I mean, LMU is fine as well. Actually, let's make that point as well. Like LMU is genuinely fine because we also have a kickoff, especially like in the city center, for people that do like management technology, for example, at TUM. Like we are not only STEM students; we also can take in like basically like everyone that just wants to work on cool stuff and just wants to help make stuff happen.
Yes, exactly. So as you can see on your screen, we have this QR code with our kickoff page. We will have our kickoffs in the next couple of weeks. So if you are interested, if you just want to see what a difference you can make, you can go on that website and meet us at our kickoffs, which would be really cool. We would really enjoy if you joined us. And yeah, it's a really great way to make friends as well here at university. I made so many people who I didn't know anyone from aerospace before joining, and now there are so many aerospace people I can just ask
like
stuff.
I didn't know anyone from computer science, and I know people from computer science. It's also like great bonding, like doing cool stuff, and like doing that together is also like always fun. Like I've seen you like way more days than like I would have thought.
Especially the last couple of weeks with the
getting everything
preparation here.
Yeah,
that's been really cool.
Really, really great. So,
you know, working together in a large team where everyone like works towards a goal. Like this launch that we are having today is really, really cool. And
I mean, there are so many people, and the dedication is awesome. Like for example, we have ein bisschen Direction.
Sollen wir das Mikrofon?
Vielleicht können wir den Gain ein bisschen hochschalten.
Okay.
Ganz leicht. This is a collaborative stream, so if we do anything dumb, just please tell us. Auf dem Handy habt ihr eine WhatsApp geschickt. Kann ich nicht, mein Handy ist das Ding, ist das Hotspot tatsächlich. Das ist, wie gesagt, eine sehr janky Solution heute. But yeah, back to English. Like to the dedication, like there's so many members here that, for example, Ferdi. He made this all the way, like he arrived yesterday evening from Vienna to like be here and launch and stuff. And there's like all the other guys that I don't drive from whatever places they live at to come here and just work on this and make this launch happen today. And also like a lot of people that spent the weeks, the nights, like the days and the nights in the office to just get this together, and it's awesome to see.
So let's talk a little bit about Move Up, so what we are going to do today. So what we will see for the most time of the stream today, so we should start soon, is the fueling procedure of the balloon. So we prepare, essentially we have a balloon that we want to fuel up, and we have a gondola that is below it that collects data and essentially contains our hardware and software that we want to test today. So what we also want to do, we want to have this Move Up not just as like a single launch, but rather as a launch campaign. So we want to get back into launching weather balloons regularly and essentially allowing other people, for example, external payloads. We had, for example, the
Spicy, for example. Spicy. At this point, also shout out to Spicy Bexus. They said they don't have a live stream, but they are launching today as well. During our previous launch window that we had to postpone because of weather, we had one of their payloads as a partner payload, and now they are in, I think, Kiruna,
Yeah, I think in Sweden.
and they're like somewhere in Sweden.
I'm not 100%
They're
sure.
somewhere in Sweden right now and launching today. So shout out to them. Best of luck to them. Hopefully today, 2 Munich teams do a really great balloon launch. And for example, for the upcoming missions, something that we can teaser and hopefully then talk about in the next live streams and also in the media that we produce for you guys as well is Move Up. The second mission is going to do some research regarding a pretty interesting topic actually, microplastic in like the upper high atmosphere, which is something that I wasn't aware of before I heard about it, and it's a really interesting research topic. So yeah, so if you just want to build cool stuff and also work on really, really cool and novel research topics, just join Move and join Move Up. So, yeah.
Exactly. So this is really, Move is really about learning and building cool stuff together. So even if you feel like, okay, maybe I don't know, so for example, if you're in computer science and you're like, okay, maybe I don't really know programming that well, or you feel like maybe I don't know it well enough to join. No, that's wrong. Like when I joined, I didn't know C++ and I didn't know Rust that well. And these are some of the programming languages we use in our software that will run on the balloon today. And now with like 1.5 years of being in a software team and learning a lot, it's one-sided audio. Okay, maybe that's because I'm talking to it on the left side.
It shouldn't be. I don't know. We'll try to fix it once we can do maybe an intermission once we're done with the presentation, and then we'll try. But thanks for the heads up.
Thank you. And so really, if you are interested in space, if you're interested in any of the topics, also of our other teams, we aren't just Move, we also have our rocketry team, our space labs team, and our
rocketry actually, like next week,
space robotics team as well.
Next week, Europe is happening, so rocketry is going to launch together with Space Labs as their payload from the competition in Portugal, and they also have a stream scheduled. So stay tuned to our YouTube channel actually, because there's like a bunch of stuff happening right now.
Yes.
Like every team is doing something cool right now. Like we are doing Move Up. Robotics is also in Oberpfaffenhofen doing lunar stuff, and Space Labs and rocketry are preparing for Europe. So quite a power week for WARR.
Yeah, so if you want to stay updated on these things, please feel free to join us or to follow us on our social media. Of course, on YouTube we have an Instagram for all the different teams, so you can always stay updated. And I would love to see you at our kickoffs. That would be really cool. Yes. So to tell you a bit more about the projects we do here at Move, we of course have Move Up, as you can see the balloon, which we are launching today, but we have a more general goal that we are working towards, and that is Move 3. So Move 3 is our next generation satellite that should sehr leise das Okay. Können wir das
noch mal Gain ein bisschen hoch.
Wie hoch können
Danke.
wir
Ja, bei mir ist jetzt richtig gut. Okay, das machen wir einfach auf Max.
Sprech mal, wenn du so...
1, 2. So like our OBS tells me like really red and really loud. So hopefully I am not breaking your ears right now. But hopefully the audio should be fine. Like I mean yeah, you can troubleshoot with me. Like you can see the OBS go really red.
Wait, I will go somewhere else to hear that.
Yeah. So hi everyone. Hopefully I have not broken the speaker. But yeah, because like my OBS tells me it's that's way off. Was denkst du?
Es ist nicht besonders laut, wenn ich es auf maximale Lautstärke habe.
Ja, es ist halt glaube ich auch viel Wind. I mean, this is the setup we are running. If you want to see that, but
Ich krieg gleich das Audio, wo du es auf hoch gestellt hast.
machen wir mal. Was sagt der Chat?
Too loud.
Too loud, yeah, I thought so.
Ja, aber only left channel. Can you think of things umstellen?
What? Vielleicht guck mal in die Einstellungen.
We're definitely sorry if you got something too loud.
Left to right balance is normal.
Can you change the balance somehow?
Es ist ja genau damit so. Deswegen wundert mich das gerade. Vielleicht soll ich es einfach mehr.
Ist das hier nur das linke und dann der untere Bar wäre das rechte, aber...
Ah, stimmt. True, das ist... Ja, okay, true, ihr habt recht. Warte mal kurz.
Maybe if we change this to a different orientation, what if we put it like into the middle of this?
Das war das, oder?
Können wir das Mikro irgendwie so umschwenken, dass es einfach sehr nah bei uns ist?
Ja, das können wir machen.
Kann ich das hier wegmachen?
Aber ja, stimmt, das macht nur auf eine Seite. Das hat doch gerade in der Video auch nicht auf eine Seite gemacht.
Kann ich das einfach so nehmen?
So yeah, troubleshooting never stops. Also not with live streams. But yeah, we are aerospace engineers, not Twitch streamers. So it happens. Aber ich glaube nicht, dass du was im Stand, wenn du das änderst.
Okay.
Und dann muss ich das Software-Seite.
Solange es hält.
Es sollte eigentlich.
Können wir den so rüber machen und dann ist...
Kannst du mal, das ist ja von Jakob Zöllner. Kannst du vielleicht den mal fragen? So yeah, I mean, you hear me on the left ear. The left ear. Take like your earbuds and listen to some music on the other ear, I guess. In the meantime, Philip is asking Jakob for some info about the microphone setup that we're using. Auf deinem? Ach so, ja, stimmt. Wir können ja einfach deine Kopfhörer nehmen. True.
Ich hab nur bei dem einen einen Mappen.
Ja, aber dann machen wir einfach das Switch.
Oder sollen wir beide nehmen?
Sollen wir es nicht weiter nach hinten machen oder so?
Ja.
Haben wir einen USB-C-Port?
Ja, sollten wir haben.
Wo mit
So,
viel
ja,
Clearance ist?
We are plugging in our different microphone to fix the...
Test.
Okay. Muss ich jetzt nur noch importieren. Warte mal, ich mach mal. So you're gonna stop hearing me now.
Ach so, oh. Jemand
Ja.
meinte, wir sollen hier Mono klicken einfach. Ich meine, das würde Sinn machen.
Read the chat. Klick Mono. I'm so sorry. Okay.
So, lass einfach dieses Mikrofon.
Ja, es ist true. Warte mal. Ich probiere das. Ich will das mal actually probieren. Warte, Audio Input. Hallo? Oh, ist zwischen. Okay.
Ja.
Dann muss ich das. Aber ich sag beide.
Is this working now? Which microphone are we using right now?
Wir benutzen jetzt gerade deins.
Okay.
Okay.
So apparently it's.
Ja, hi Egi.
I hope I'm not too loud.
Steel City, I am so sorry. I am so sorry. The chat has quite a lot of delay. I'm so sorry.
Nice. Okay, that's.
But yeah, we should just go back to it. As I said, aerospace engineers, not Twitch streamers.
But we're trying. We're trying.
We're doing our best.
We definitely want to do more live streams like this. So if we have a new balloon launch in a couple of months, I hope, then we will definitely stream that. I also have a micro.
Oh, you also? Oh, okay,
Yeah.
perfect. I think Move Up 1 should be next summer, so basically a year. So you have enough time to join us and like develop the project with us together.
Let's go to
Just
the
like
presentation.
audio-wise, just write in the chat if anything is wrong. Perfect.
Okay, so to tell you a bit more about our projects, so the large project we are working towards is Move 3. Move 3 is a 3U satellite, so this is a unit of essentially CubeSats. So 1U means we have like a 10 by 10 by 10 centimeter box that contains, for example, hardware or sensors. And we want to build a 3U satellite, so a 30 by 10 by 10 centimeter satellite that is able to measure space debris right on orbit. So what we are currently developing is DETRA, which is a space debris sensor, which essentially measures space debris that impacts like our satellite, or in this case, a box that is specifically designed to survive these impacts. We want to measure, for example, space debris, particles, or for example, paint flakes from rocket stages,
Yes.
and other debris that just is out in space that's really, really small that you can't really detect from the ground. So our solution is to send something up that gets essentially hit by particles that travel a couple of kilometers per second. I think the maximum is like 30 kilometers per second.
Yeah, should be around.
Or even more. And we want to measure and classify which kind of particles there are in low Earth orbit.
Yes.
That allows us then to inform the models of ESA and NASA, which essentially model what is the risk for your satellite, where should you send it. And
yeah, I mean, these particles are basically like, maybe some of you have heard the term like TLE. Like these are like TLE are two-line elements of like objects in space that have all the information necessary to basically describe their orbit. And the particles that we're talking about detecting with DEDRA, these particles don't have TLEs because they're like way too small to track them. Like institutions, for example, like NORAD, they have like a vested interest in tracking everything in space, and they are just way too small. And so we have statistical models approximating where the clouds are, and DEDRA plays like a pretty important role and is in its way, like as a student project, a really unique project that I haven't really seen anywhere else in the form. Improving
Audio
these
quasi ganz weg.
Audio nun quasi ganz weg. Okay.
That's concerning.
Nee, bei mir sagt er, ist da.
11:28.
Bringt mir auch nicht so viel. Ich weiß, es ist ein Livestream. 11:28. Wobei. Aber Audio. Hast du Audio? Yeah, okay. We have audio on our like check stream, so maybe I don't know. Maybe 11:28 is like when we were muting ourselves and checking stuff. Nee, also wir haben ja den Stream
it
hier.
was just right now. So,
Ach so. Na, okay, sorry.
let's see.
Ja.
I guess we are back. I mean,
Sind wir jetzt wieder da?
okay, yeah, I think it's working.
Ich kann
on my
euch gut
side.
hören. Ja, okay, danke.
So,
Yeah, basically DEDRA is a very unique student project that doesn't really exist in any other, like like, maybe there is, but like it's a pretty unique student project that is like quite interesting. And if you want to work on something like this, as I said, just come to the kickoffs. Yeah, so our checklist guy had made some announcements. Probably like fueling procedure and stuff is gonna start happening.
looks like
soon.
we're gonna see something interesting happening in the next couple of minutes. So, I already told you that we have a couple of satellites that are in orbit right now that we are also talking to. The one we are talking to is the one in the middle, which is Move2. So it's a 1U CubeSat, and it was used to test like new solar cells, which are really cool. It launched in 2018, and we are again still talking to it. There's also First Move, which was the first satellite that was launched, or that was built and launched then here at TUM. So it was launched in Russia, I think.
Yes.
And there's also Move2B, which, as I told you earlier, has re-entered the atmosphere at the end of 2023.
Yes, I mean the launch in Russia was kind of cool. Like with the First Move one, it's like they used like one of the silo-propelled like ICBM rockets. Like so they just
they repurposed that.
Yeah, they're like pretty
cool
cool stuff. But more recent thing that we launched is that you have spent like quite a lot of time on working is Flyer Circuit. Thanks to the folks over at Aurora Tech, we were able to launch a not yet launched. Pretty careful with the words. We shipped it.
Exactly, we shipped it.
Yeah.
We can tell you more about it. So what the so-called Student Technology on CubeSat or STONKS project is all about is testing our new technology. So as you can see, the last launch we had was in 2019, and we haven't been sleeping. We've been doing a lot of projects, we've been building things, and what's really cool is that we got the opportunity to add like a 6 by 6 centimeter plate, a circuit board to a satellite. And this will allow us to test newly developed sun sensors. So if you take a look at this image, this is the actual part that we then tested and sent off that will get to space. And what you can see here is that we used like a testing setup that shines a really, really bright light at this sensor. So we have actually 3 sensors on it. We will show you in the next couple of slides. So what we have is like a testing setup that sends like a really bright beam of light into our sun sensors. And what sun sensors are used for is the so-called ADCS system. ADCS stands for Attitude,
Determination and Control System, yes.
Perfect, I sometimes get that wrong. And what it is essentially used for is that you know where your satellite is currently pointing. So, for example, if you want to send data back to the ground station of your satellite, you need to point it, depending on the frequency type that you use, you need to point it like very specifically, for example, towards the roof in Garching.
Yes, pretty much.
And if you know where the sun is and where you are, then you can essentially determine where you are pointing right now and how you need to adjust your orientation to actually point towards the ground station for sending down data. And what these sun sensors can be used for is essentially getting the angle towards the sun. We have 2 different types of sensors on there. Actually, we have 3 different sensors. 2 of them are somewhat similar. One of them is quite different. 2 of these sensors essentially tell us the angle that the sun is shining at. And the other sensor tells us whether the light we are currently getting is a reflection from the Earth or from the moon. And that because we need to ignore these. So we really want to know where is the sun coming from, and we don't want to get confused, for example, by reflections from the atmosphere. Yes. And that's essentially what this board is testing. It is, of course, also testing our software. It is testing a newly developed bootloader that a couple of people and I have been writing. So this will be really, really cool to see. We will definitely update you on our social media channels when we actually have a launch date. And yeah, let's take a closer look at this board. So what you can also see, we have here the board with its cover, and we have a couple of sun sensors which are located here. So here's the sun sensor that detects whether or not the sun, if we are getting light from the sun or from the Earth or from a reflection, essentially. And there we have the 2 other sun sensors that tell us the angle at which the light is coming from. And you can see we have this plate on here where a lot of the people who worked on the project actually signed it. So they know now there's something going to space that they actually signed. So if you think this is cool, again, either follow us on our social media channels or, well, just join us.
I mean, the best way to
this kind of stuff.
The best way to get your name on that is to join us. Our balloon also has that. I mean, the balloon actually, funny enough, like I'm gonna do like some stuff for the recovery. And the balloon has basically the names to contact us if you're like a what's Bauer? Like Bauer in English, basically a farmer. Yeah, if you're a farmer that happens to find our balloon like in between your produce, we have a phone number that you can call and then please return. And also like inside there's the name of the people that have worked on the project. So it's yeah. So yeah, if you want to get your name out there, figuratively and literally, join us. So I think the next one is software.
Okay, we talked a bit about software already. So what we are really using on this board is DOSIS, which is our distributed operating system. So it's essentially an operating system that you can run on multiple chips at once and it will work together. This is something we will need for Move 3. Because Move 3 consists of multiple subsystems that need to work together. So there's, for example, a communications part, there's a part that, of course, measures our space debris, which is our main payload. And all these need to work together, and DOSIS is the part that makes this happen. We also have our bootloader. Again, this was developed by a couple of people here. And what's really cool about this bootloader is that with the combination of the hardware and the software we are using, we can essentially detect when we get hit, for example, by radiation that affects our storage. So if you get like a bit flip inside of our storage, we can detect it, and the bootloader will then make sure that the operating system can be fixed, even if we get these kinds of radiation effects.
For the uninitiated, a bit flip is if radiation that is a bit higher. And like in the LEO, you still have effects of the Earth magnetic field, but especially in deep space applications, this is a real worry that you have, because in space without magnetic fields, you get radiation, and radiation causes your bits to flip, meaning 0 to 1, 1 to 0. But yeah, so we write software to combat that.
Yes.
So I think next slide, I guess.
So what we can also show you, what's really cool, is a video that we have prepared. So I already told you about our sun sensors and how they are supposed to measure the angle at which the sun is coming in. And of course we need to test this on the ground to make sure that what we are doing actually works. And we built essentially like a really, really bright beamer that is supposed to simulate the power of the sun.
The sun is a deadly laser.
The sun is a deadly laser if you're out there. And essentially what we did was build a testing setup, or we used one that already exists. Someone built that before us, or before my time when I joined 1.5 years ago. So
should I just play the video, I guess?
we can play the video. So what you can see with the setup is that we essentially rotate our board into an orientation where we know what the value should be. So we know, okay, at this specific point where the motor is holding the board, we know we have this specific angle. And then we can validate our software to make sure that it actually produces that value that we are expecting. And then we calibrated it and essentially made sure that the values we are getting also make sense here. And with these data, we can then in the future power our ADCS system to know where the sun is and then where we are pointing, which is really, really cool that we get the opportunity to actually test this in space. But this is a ground test, which is also really, really cool.
Yeah, I think right now we can maybe show that. Let me see. Let me just.
Sieht eigentlich gut aus.
Ja, ich glaube, unsere Webcam ist frozen. Ich mache die nochmal neu rein.
Okay. Ja, das ist jetzt noch
so.
I hope we are still.
I think
you can
loud,
still hear us.
Loud. There we go. Test. Okay. So I hope we didn't die the stream. But yeah, no, people move. There we go. So yeah, as you can see, the launch crew is folding out basically the ground that they're gonna start working on. The balloon that they will use is quite fragile, so they will take their shoes off in the blue area and yeah, basically just handle the balloon with care. There are multiple people that all know their roles, so yeah, there's people to like make sure that the balloon doesn't fly away. I mean, we do have the roof now, but yeah, I didn't wanna set up the webcam. Like,
that's fine.
The webcam is not set up yet because I do kind of want to show you what people are doing.
Yes.
But let me just, I mean, they just set it up now. Let me just change that real quick. Yeah, I mean, this is a real behind-the-scenes look at Move. You can see how I set up the stream as well. There we go. Real behind-the-scenes, guys. Whoop. If you think you are better at live streaming, the PR department always looks for people. So use the QR code to join us. And there we go. Nice. Yeah, so basically the balloon is quite fragile. People know what they're doing. They have the roles and make sure that the balloon only bursts when it's supposed to. At this point, maybe we can talk about like how the flight profile is going to look. So basically, you have a balloon that you fill up with a bunch of helium. And the way we control the altitude is that basically the balloon is designed to just burst. So we expect a flight altitude of right about 36 kilometers. At 36 kilometers, basically because the air pressure just gets lower and the pressure of the helium inside the balloon is higher, the balloon cannot take that anymore, it just bursts. And then the parachute just makes sure that our gondola doesn't break when landing, so we can retrieve it. The cool thing about balloons is the parachute and stuff is like pretty much guaranteed to work because there's not really any kind of deployment mechanism. We can just let the parachute hang during ascent because the drag isn't of any consideration with a helium balloon. The guys over at Rocketry had experiences with recovery, but yeah. So our recovery is not as not. I mean, it's just a parachute
There's
that
no
just
software
hangs.
that can break
There's
it.
no software that can break it. There's not a whole lot of stuff that can happen. So yeah, it's a pretty cool thing, I think, when stuff is like just designed based on pressures to just burst, and like a pretty elegant way of determining the altitude, I think.
What's also really cool is that we will send down data during the launch. So we will get, for example, GPS beacons
Yes.
and similar data, temperature data as well. So what's typical for satellites is that they send out pulses of data. So they, for example, report internal temperatures and similar things. And we are doing the same thing using the same software mechanisms as we would on a real satellite, or what we will do in Move 3, but we will do it on the balloon. So this balloon program is really what helps us learn how to build hardware, how to use it, how to essentially then make the software work and make our ground stations work as well. And then we will learn from what went well, what didn't go that well.
Yeah.
And
I mean, right now you can see the guys that are going to hold the balloon taking on their gloves, like white gloves. So it's going to be with a lot of care. You can also see Lucas walking through this shot. Do you want to say something, Lucas? I mean, let me interview you. Let me interview you. So, Lucas, today, what are your hopes for the day, and what are you working on?
Well, I'm first of all hoping for a successful launch, right? It's the first mission for the Move Up balloon system. And then, of course, testing the systems we have on board, the battery boards and comm system parts. Yeah.
So, are you are you doing stuff during launch, or are you only recovery?
Oh, I'm also doing stuff during launch. I'm responsible for holding the gondola and preparing the gondola for takeoff. Yeah,
don't
exactly.
let it out too early.
So yeah, what's like some like for people who don't really know, like what's it like just launching a balloon? Is it just like, I don't know, going to Oktoberfest, getting a helium balloon and just leaving, like letting it out your hand, or is there like anything to it? Like what do you need to consider while?
It's slightly more involved. For example, you're not allowed to touch the balloon itself. You're only allowed to touch attachments, so the like or with gloves, of course. With gloves you are allowed to, because the latex the balloon is made out of is really thin and really easily damaged by oils in your skin. So that's something you have to be careful of. And then of course everything has to be is bigger, everything has to be done slower, more carefully. Yeah, just
So they seem to be unpacking.
Yeah, they seem to be unpacking the balloon now. Is that, yeah, that's the balloon. Quite interesting. So we have 15 minutes till the launch window opens. I think feeling time wise, do you want to have some words to say, our launch director? Do we have some time? Does our launch director have time?
I mean, sure.
Okay, so
Feedback, yeah.
so what are your hopes for the day? How is it going? Is everything according to plan?
Oh yeah, it's actually. Oh, wait. It's actually going quite good. I'm kind of excited for the launch. Everything seems to go to plan.
Yeah, the weather's looking way better than when we came here.
Yeah,
That's really nice.
We're receiving our data from the gondola right now, or we receive the data. We also receive the GPS beacons. APIS is looking good. Stratofinder is looking good. It's kind of awesome.
Okay.
Yeah.
For the people that don't know what APIS is.
APIS is it stands for Automated Position Reporting System or Automated Packet Reporting System, either of the two. It's basically a little protocol that spits out location as well as like other essential data, for example, temperature and air pressure. And then that all gets relayed with various ground stations to a website, which we right now cannot track because probably none of the ground stations see us.
Yeah, once we're in the air, that should go
Yeah,
away.
however, yeah, it's gonna go away if, or it's gonna appear when we're airborne. Right now, we actually see our.
Yeah,
Yeah,
we're unpacking the balloon right now. While they're unpacking, one last question.
Yes.
I mean, I think I'm dressed quite nicely, but like, why are you in a suit?
I got bullied into it. It's apparently it's tradition for the flight director to wear a suit.
Okay.
That's really cool.
And I kind of like my outfit, to be
Yeah,
honest.
you look
I also
fabulous.
think
I love
it's
it.
really cool.
You look fabulous. So yeah,
Yeah, sadly not in move merch.
Yeah,
though,
maybe we need like a move suit.
a move tie would be
I like
awesome.
my VAR
shirts would be
beanie.
awesome.
Or like a
Or
rocket,
VAR
like a
shirts.
VAR shirt,
Yeah.
like starts as
Like
rocketry and then
VAR
goes to.
Oh.
dress shirts
I'm
would
getting,
be
I'm
awesome.
giving funny ideas right now.
Oh yes.
Like,
Also the Christmas sweater. Please
Oh yeah,
bring up the
like
Christmas.
for everyone not part. Wo ist das Ganze eigentlich? So where are we at? And Tom actually has a hangar. I mean, as you can see, like if you look here, or like, if you look in between Lilu and Jakob, you can see Holzapfel's like optionally piloted aircraft, and here's Lilu, our student lead.
Hi everyone.
And yeah, so basically that's where we are. We're in the hangar of the TUM. The HM also shares a part here, and yeah, so we are.
It's in Oberpfaffenhofen.
Oberpfaffenhofen, true.
So it's an airport here that we can launch from.
It's basically Munich's Sonderflughafen, so an airport that is specifically designed for companies to design their products. There's not a bunch of air traffic here, so we can just give the tower a call once we're launching. So it's quite kind of, it's more relaxed than launching a balloon from EDDM, so like the big Munich aircraft.
We also already saw a couple of airplanes.
Oh yeah, true.
Oh yeah,
true.
like the DLR airplanes.
Yeah.
They were
Like-
quite amazing to see them.
Yeah, I
or
mean,
to see
you
at
can
the
talk.
start.
You're allowed to talk about them. You're not allowed. Yeah, you can allow.
We
Yeah.
can talk
Yeah, we can
about
talk. We are not
Yeah,
allowed to film
that's
them.
so
Yeah,
starting.
yeah, we
Okay,
can. Yeah.
Plane start and
Yeah.
and it's kind of awesome.
A
to
ham
see
radio for communications or something proprietary. I think
I mean,
APRS
basic-
is
I
like
mean,
an
we-
amateur radio thing.
I mean,
But
we
I'm not
work on
100%
amateur
sure.
radio frequencies, so it is basically a ham radio. So we use an SDR with an antenna to basically on the amateur radio frequencies to receive the signals of the balloon. I mean, I, for example, and Lido, for example, both have ham radio licenses.
too.
Jakob as well.
I'm the only
I am
one
so
without
sorry.
a radio license.
I mean,
here.
basically, like us three here all have amateur radio licenses. Also because I'm part of mission control. Lido used to lead the mission control
Yeah,
team.
it was very fun, but now I have different jobs, so I don't get to do it as often.
Yeah. So
I
yeah.
still have to finish my training.
So if you are interested in ham radio operations, I could interest you into the mission control team at Move. That's where you can get your license. If you already have your license, welcome to Move your mission controller after some training.
We do
You
training.
can
We do-
directly talk to a currently in orbit satellite. So
Yeah,
if
I mean,
that's
that's the
something that
coolest
sounds
thing.
interesting
Like
to
in
you,
between
do it.
lectures, we have a sun-synchronous orbit for our satellite, so it roughly appears above Garching, like around about the same time. Which is, I don't know how it is with like summertime and wintertime, but when I used to do the overpass, it's around 10, 11, 12ish.
Okay, I'm gonna go.
Yeah, our launch director has to do launch directing.
So now you gotta live with me.
No, this is our fabulous student lead. So yeah, if you want to know what's going on at Move, she is the one to talk to. So
Yeah.
what's going on at Move, and what are your hopes for the day?
Yeah, so my hopes for the day are first that we launched the balloon. I'm very excited. I was quite sad that we had to postpone the initial date because of weather concerns. And yeah, then we're gonna hop right into the preparation of the new semester. I heard that you already talked about the kickoffs. There's some planning going on for that, and then obviously making the plan on what to do during the next semester, getting some funding.
Can we share the call sign?
I think I would need to check with Jakob
Yeah.
on that.
At this point, no, but yeah. At this point, no.
Maybe we will see.
So, for example, we have posted the link in the ERSI group chat. I hope ERSIs are not watching. I think you have math pre-course right now. But if you are actually watching math pre-course, like the stream during the math pre-course, you're doing your first steps to become a proper aerospace student. Yeah, so for ERSIs that are just joining at Move, like what's the WARR, what's Move, like what should they know?
So one thing that's important to keep in mind is that we're all about education. So while we do awesome technical stuff, our main focus is the practical education of students. So at least we at Move have the philosophy that you don't need to know anything to join. Obviously, if you already have knowledge, that's a big plus, because that means you can start in with the technical work right away and don't need to do as much training. But if you don't know anything, if you just want to try something out, join us. The only thing we ask about is that you are enthusiastic and that you're committed to working with us. And so yeah, we have a lot of different teams. We have the design teams, and we have the implementation teams. Then we also have mission control, which is a bit outside of the whole structure. So yeah, there is something for anybody. No matter if you're interested in structures, we have the mechanical team. If you want to do electronics, there's the electrical team. We have the EPS design team, which is all about power, which is also important for today.
Yeah.
And yeah, then we have the other teams like PR.
Hi.
Thanks to JJ for organizing this awesome stream and the setup here today.
Yeah, the chat helped. Actually, genuinely, I want to shout out the chat. Thanks a lot for helping with this audio and genuinely everything. Yeah, speaking of power for today, one important component that we're actually testing is our battery boards. Yisheng did a lot of work in the last few days, and so we're just looking at how well our battery boards perform today, integrate with the backplane, and just see how it just performs during flight operations. So yeah. So as you can see right now, they are rolling up the balloon back in again. I think. Yeah. So the launch crew is doing further launch crew stuff. So I think we are changing. We have like a bunch of balloons with us. I think we are changing the balloon that we're using, or.
I mean, I can go and check.
Yeah, so we just get some information what's going on right now. I mean, it's we have a bunch of balloons with us, so it's no biggie. So what else can we talk about while we launch? I mean, the launch window is from 12 to 14, so you have the potential to receive quite some entertainment today. So the launch window would open in 6 minutes. We will probably not launch at 12, so they are changing the balloon, I think. So we will probably launch, I think, like in some time during the 12 to 14. That's when we have the license from the regulatory bodies. Although Oberpfaffenhofen doesn't have that much traffic, it's still an airport after all, so you still have to obey those. So yeah. I think we talked about this when you joined, or maybe Friedrich has some time. Do you have some time to talk? Yeah, okay. So yeah, you will talk to our other student lead in a minute, while the other guys are doing some work. Yeah, they're just unpacking the other balloon now, I think.
So yeah, we have a fixed fueling procedure that they are following, and that essentially makes sure that we are doing it correctly, doing it safely. And if we now notice, okay, we need to use a different balloon, there's a procedure.
That's a completely normal thing to do. That's why we pack multiple balloons. And that's why we also have a really, really long checklist. And if one of the checks comes out that we change the balloon, we change the balloon. So, hi.
Cheers.
That is Friedrich Kempen, our student lead of WARR Move, together with Lilu. We just had Lilu here. I mean, I asked this question, everyone, like, what's your hopes for today? What's your aspirations?
Obviously that the launch will just run smoothly and that we'll grab the balloon and have a successful recovery as soon as possible. You already went through what we're testing today, right?
Yeah, I mean, we can go over it again as well. We mentioned the battery boards that Yishin has spent quite a lot of time working on. So the battery boards are going to be quite important for our Move 3 mission. They're going to supply every our subsystems with power and the whole satellite. And we're just looking at how they will behave during launch conditions, during the temperatures up there, and just seeing how well it integrates with the rest of the bus, basically. So what other important? I mean, we also are testing our capabilities of receiving signals, communicating with the gondola. So this is also like the start of our whole like balloon project and mission, as we just like announced at the beginning of the stream for everyone coming back in. This is the start of a bunch of balloon missions that Move will undertake to research a lot of different topics and to also continue development for satellite components. So if you want to like help develop satellite components and also maybe detect some microplastics in the upper atmosphere, come join us and work with it. Yeah. Do you have anything else to add?
I don't think so. I mean, as you said, it's like the first of many steps we are willing to take in the field of atmospheric research. Did you already went through the concrete plans for next year that we're currently working on?
I mean, basically, move up mission like next summer. That's it's going to be the next launch campaign that you can take part in, where we will be launching another balloon, improving the characteristics of the balloon, adding some capabilities that the balloon right now does not have, and yeah, also maybe not maybe, but like we will detect microplastics in the upper atmosphere. There's a maybe of whom we'll do it, but there's also the chance that we also can add like different payloads. I mean, before we had to postpone our launch, Spicy were to launch with us together as like as a payload share. They are launching today now in Sweden, so big shout out to them. Sadly, they don't have a stream to shout out.
Ah, that's too bad. But yeah, greetings to Spicy. Thank you so much for your assistance and help as well. Basically, this whole project with Move Up started because we wanted to work with another project of WARR, Space Labs. And basically, this entire project is just a history of possible shared launches and shared payloads, just to end up in us basically testing pretty much everything ourselves.
Fine, I'll do it myself.
Exactly.
But now we learn how to do these launches, and then we'll be able to have payloads on our next balloon missions. So that's really, really cool.
So yeah, if you're willing to maybe join Move specifically for the balloon research next year, you are probably in the one team of ours that is going to work with lots of other projects from other universities as well.
Yeah. And you get the ability to like maybe some of you like if you don't know me, like most of you won't know me, but I used to be ASD like a year ago, and now I'm taking part in my first launch campaign. So if you want to take part in launch campaigns really quickly and like see the whole development cycle, Move Up is the team for you to join. So yeah, that's honestly like one of the biggest. Like, this is I think the killer argument to join Move Up. So
totally agree. Yeah. Also, if you are a new student or an upcoming student at one of Munich's universities, don't be afraid to. Fair enough. Don't be afraid to join a student project like ours. Some of them have some restrictions that you are only allowed to join in the third semester. It really depends. In our case, we are always open for first years as well. I myself started my second semester 4 years ago. No, 3 years ago. 3.5. It's still quite some time since then. Highly recommend it. I wouldn't change it for a day. So yeah, by all means, we hope to see lots of you to join us in our kickoffs at the end of this month.
A quick update on the launch procedure. As we suspected, the balloon has been changed. So as we described, we have multiple balloons packed. It's totally normal to change out balloons. Now the further steps in our checklist are being done, and the launch procedure is happening as expected and planned.
Yeah. In addition to that, the battery boards are now in nominal mode. We are also receiving the live GPS data from the balloon, so everything is set up quite nicely. Recovery preparation is also coming along quite well. I think everybody is charged and psyched up to go on this little journey.
Drive like a 2 hour, maybe on our route. Like it's gonna be like the balloon is gonna take around about like 2.5 hours, and we will take like 2 hours. So it's gonna be quite a journey for us to catch it. So yeah. I haven't prepared a Spotify playlist yet. I think maybe we should set one up like a Spotify jam or something for the drive. But yeah, you can see. I mean, yeah, you can see basically, it's a bit small on your screen. I sadly cannot further zoom in, but if you see the white gloves behind the white gloves, or behind the person behind the, okay, now you see him, the beanie guy. That's our checklist guy. So the beanie guy, he's gonna like check everything that we need to do in correct procedure and correct running. We had multiple test runs, fueling it up. Maybe you've watched a trailer of this live stream or on our Instagram. You've seen the one scene where we hold up like a trash bag. That was a simulated, basically balloon. That was like basically a practice run. We are not really filling it up or anything. It's just to like test multiple times. Okay, how do people engage with the hardware that they use, and like how do they act together with it? I think, yeah. So yeah, we just changed. We have multiple operations of the checklist, so it's pretty much like the German word, like idiotensicher. So like you don't have to do a lot of thinking. It's all written out clearly as it should be in aerospace. To just do everything as it should be.
Yeah, that's right.
Yeah.
Did you already give a quick run through to everybody working today?
I haven't gone through all the
if you
names.
are willing, I could go through.
Yeah,
this.
go through all the names.
So the aforementioned beanie guy is Vincent. He's pretty much the one in charge of ensuring that the full launch procedure is going as planned. Hence him running around and telling people what to do and being quite stern with them, because discipline is really off order here. The slightest mistake could mean a complete systems failure. As well, you already met Ferdi earlier, possibly. Was he here already?
Yeah, Ferdi wasn't here yet. Ferdi is part of the launch crew. You can see him. Yeah, wave Ferdi. Hi. we shouldn't disrupt the launch crew. But yeah.
Yeah. So that's Ferdi. In addition, you also have Michi, the guy with the glasses right next to him. He is one of our mechanical leads in Move, and is not only an expert regarding anything that is outside work for Move Up, but also the satellite structure system and mechanisms. And of course, our launch director, currently holding that roll of tape, that's Jakob. Yeah, we've got two Jakobs managing the balloon. Yeah, he's the one who made everything around here possible today. So, but yeah, it's true. Maybe we can get them later for a short interview or something.
Jakob, the Jakob Z did Suit Jakob today. Suit Jakob already did an interview. We just need to get Hoodie Jakob here.
Hoodie Jakob is quite busy still. Yeah. I think you might get him after the balloon.
I think, yeah, after the balloon has launched. Yeah. So yeah, lots of work going on right now. But maybe you have some questions in the chat. Like always, also just use the chat. Like maybe you have some.
Is the call sign public, or would you rather not share? No, the call sign is not public for the simple reason that pretty much everything around the recovery is still internal only. Maybe in the future, we already discussed this for this launch, but we decided against it. We'll have a balloon launch with a public call sign to also connect with amateur radio amateurs around, well, basically the launch site, and whoever is interested, really.
Maybe
what else? Do you use ham radio for communications or something proprietary? Yeah, we use ham radio. There is pretty much no proprietary software that is used, to my knowledge. There might be some additional data analysis tools we might use, but I think even that, pretty much our entire software team is a big fan of open source software, so everything around it is kept that way. And the same is for our satellite communication. The satellite itself that's currently in orbit and talked to via our mission control team, that uses only amateur radio in the ultra-high frequency range.
That's also why you need, in Germany, it's the Klasse A. The Klasse A have radio license. So if you already have one of those, you are a perfect candidate for a mission control team. If you want to get one of those, you are also a perfect candidate for a mission control team. I got one of those during my first semester, so don't be afraid joining student clubs during first semesters. You need to be a bit smart choosing what to do, and of course, like always first semesters, GOP is pretty important, but you have time if you manage it wisely to join student clubs, and I did, and I don't regret it.
Maybe we should recommend it.
Yeah, of course.
Maybe we should recommend. Like, I recommend it. That's a better word.
I recommend it too.
Yeah.
Me too. You should join a student club.
Join a student club.
No, but seriously, the reason we are Thank you. The reason we are pushing this so much, as you can tell, our kickoffs are nearing. This is normally the main entry point for our new members.
Yeah.
So, of course, we're trying to make lots of advertisement for us, but the WARR in general.
Yeah. Speaking of the WARR in general, not only we are launching today, next week Euroc is happening, and SpaceX and Rocketry together, like SpaceX as a payload and Rocketry as part of the competition, are launching in Portugal from Euroc, and they also have prepared a live stream. So if you look in the live stream chapter in YouTube, you can get a reminder for that one as well next week.
Again, follow the war.tom Instagram account, where we will always post the updates from all our teams, so you will never miss anything, even so live streams, all our updates and so on.
Yeah.
Definitely. The rocketry launches in general are never something to miss. They are just completely amazing, always very well documented and very well managed. And their live streams are always a pleasure.
Shout out to Benji. Shout out to Benji. Love you.
But yeah, we're climbing higher today. At least we've got that running.
Yeah, we will today. I mean, we always are the highest team in the student club. Only speaking of satellites. And today we are launching quite high, 36 kilometers, and that's where the balloon will pop. As explained before, the way helium balloons work is the internal pressure is way higher than the external pressure at high altitudes, and the balloon is not able to take up that stress, and at that altitude breaks. We are able to control a little bit, let's talk maybe about controllability of like steering and stuff. We do not have like any sort of system to steer the parachute. That's something that we might look into the future, but the way we can control our flight is we can fill different amounts of helium, so the descent and so the ascent rate can change, and depending on how you like do your mass budgets and what kind of parachutes you use, you can just adjust the descent rates, and with those two factors you can basically adjust how the balloon flies, and the rest is basically up to the wind.
Yeah.
So launch window.
Yeah, the launch window as of now has started at 12, and we have a full launch window until 14.
So we have still a bunch of time.
We still got enough time. The launch itself will be pretty straightforward and pretty fast. As soon as the gondola is fully integrated, they're still working on the cords connecting the gondola to the rest of our structure. As soon as that's finished, the fueling procedure will start. We'll connect the gondola to the balloon, and then we'll just wait for, as soon as everything is finished, for the green light from the local tower that we may launch. So, yeah, until then, everything should be pretty much finished. We've got one more question. Will the mission be trackable on a public APRS tracker site? No, not this time.
Today, recovery is a bit more private.
Yeah, especially since we are really intent on grabbing our payload back, because we pretty much need those battery boards for full analyses as soon as we got them back. Hey, you got full management.
Oh, we got the whole upper management. Yeah. So, maybe like, how is it like to lead like a student club? Like, that's maybe something that we can talk about a little bit.
I mean, I'm the one. I'm just gonna steal
Philip's
chair. So, I mean, I haven't been a student lead for too long. I started in March this year, so it's been about half a year. It's quite crazy leading about like over 100 people at age 21, 22. It's definitely been an experience, and I'm really happy that I can do it together with Friedrich, and we share the burden a bit, especially because obviously you still have your studies besides besides the team. So yeah, we share the responsibilities and also give each other ideas, which really helps.
Okay. Quick launch update. I think now they're inserting basically a nozzle, like basically the device that will fill up the balloon with the helium inside of the balloon now. They will secure that nozzle with basically different ways of securing it. I am part of the recovery team, as you can tell.
It's pretty much lots of specialized duct tape. We are engineers. We use duct tape.
In aerospace also, like oftentimes called speed tape. Hopefully. So everything is, I think, pretty much still going to
also spoken to the team taking care of like thinking about receiving the GPS data, and they seem to be very happy about their progress. And they've tested 2 different ground station setups for the ones that will be here.
The live stream is very quiet.
Maybe we should speak up a little.
Speak
or
up a little. I can
we
increase the
dial it
gain a little bit.
Ah, sweet. All right.
If it's too loud, just tell me. Yeah.
You
so-
could never be too loud, JJ.
I mean, this is a collaborative live stream, so just work with us to make it happen. So yeah, they have now securing it with they're now securing the nozzle to the balloon, and as soon as the nozzle is secured through that device, the helium is going to be filled into the balloon. I think it's going to be quite a funny picture to have it to have the filled up balloon inside this hole, and once we are ready to launch and we have got the permits and so what, we will open up the hangar doors and let the balloon out. Also, always feel free to ask questions. So yeah,
Be it about the balloons, satellites, or just how everybody is doing.
Oh.
I think the
50% zip ties, 50% duct tape, as always.
there we go. Yeah, of course. Yeah, generally speaking, as you can already tell, lots of the people here are somewhat tired. I think all of us had a rather early morning today, since
Yeah.
we had to arrive at Garching to grab all of our stuff at 7 and then be here by 8. There were also some stories regarding that little transit here. I, for my part, traveled here with our lovely flight director, and the problem was that we entered the wrong address and thus ended up in a completely different neighborhood, and we're a bit confused where all of the planes are going, because they didn't land like around us. It was a bit more to like a couple kilometers northwards.
I mean, there's a bunch of Lise Meitner.
There's a bunch of
There's like a
Meitner.
lot of Lise
Yeah.
Meitner Straßes. It's like
What's
genuinely
the deal
annoying.
with that?
I believe the one there's also one in Ottobrunn where the
Um,
aerospace campus is.
I don't know what was the issue with the first balloon.
So basically, I spoke to the launch team, and there was like an imperfection in the balloon, which seemed to be from manufacturing, like a little bit of doubling up of the material. And so they decided that just for security, they were going to use the backup balloon, or at least check if the backup balloon is in a better state. And since they're now preparing to fuel the backup balloon, I believe that's the case. It's not that the first one was unusable; it was just not in an ideal state. So yeah.
Basically a safety margin. That's also why you bring multiple balloons. So yeah, that's also why the checks exist. So pretty standard procedure. Always feel free to ask more questions, of course.
I think we could show one of the antennas we're going to use.
Yes,
Oh,
that's
yeah.
actually a
Yeah.
really great idea. I think.
Yeah, I'm gonna grab
That's
one.
an awesome idea.
Basically, you've just, before Lilu became student lead, she was head of our mission control team, and
Yeah.
thus, whenever there's like an antenna, ground station, or something of this sort in a 10-kilometer radius,
That's so awesome.
you know who is going to be not only completely hooked on that topic, but know every single detail about it.
Yeah, I mean, I'm also mission control, so I
Yeah,
know
I'm
my way
surrounded by
around
mission
antennas.
controls
Yes.
today. I already talked to our mission control lead earlier that I might join mission control next
Please
semester
do, that
just
would
to
be
make
fun.
my ham radio license. Just
Yeah,
for-
do it. It's
for the
always
fun of it.
great.
All right, there
So-
we go.
So yeah.
What can you say about this antenna?
So you might see that there's like flexible measuring tape being used for the antenna, and a piece of wood as the center beam. This might look a bit DIY, but it's actually quite useful for like those mobile antennas, because contrary to like a bigger antenna made out of metal, those can flex, which makes it more easy to transport. And yeah, the important part is the connector here, which then connects to the SDR, and then we can use our laptops to get data from the satellite on the go. I'm talking too much about mission control. Of course, today we're getting data from the balloon, not from the satellite.
But I even have something to say about that antenna. 2.5 years ago, when our last balloon launched, I was part of the recovery team, actually. And this antenna was built by Benze, who was one of the recovery leads, if you will, back then. And yeah, with this little antenna, we had some, maybe you went through that story, but we had some little hiccups on the way gathering the balloon the last time. And there might still be some image floating around of us climbing up a tree and me hanging on one of these branches. up this antenna trying to find the satellite on the signal.
Today there's not going to be any climbing.
No climbing.
No climbing. We've introduced lots of new safety procedures to make sure that not only our balloon, but also our recovery team, and of course any possible bystanders are perfectly safe. Also, we are well better prepared regarding the entire launch procedure, but also recovery procedure in regards of every single method of tracking.
Yeah.
Maybe you want to go into more detail about that. I mean,
I want to go into detail of a little update right now. So the gondola, our payload, is now ready, and they are waiting to close it when they align with the procedure of the fueling procedure. So it's going well.
Very
awesome.
nice. Thank you.
So hardware is integrated.
Have one of the chairs, but we stole that from you. Quite shameless.
I believe yes, you could play music with the antenna. Although we'd rather use it to gather data.
I mean, we have a 2-hour drive. You might kill the time a little bit.
Yeah, I believe this one is going to be in the
Yeah, in my car. I don't know.
So,
Sadly, I don't play instruments.
yeah, me
You
neither.
don't?
No.
You don't?
No.
What do you play?
I started playing instruments. I mean, I am completely...
Okay, you started like 2 weeks ago and now
No, I
start
started
judging.
half a year ago. Thank you very much. As you can see, maybe music is not the strong suit of these few fellows, but our two launch and flight directors, the move up leads, both of them are quite the musical genius. Little fun fact.
True.
Yeah,
That's genuinely true. Yeah.
that is right.
Like in the after movie, you might hear some music that they have composed. So I don't know.
Maybe. Yeah. We'll see about that.
Yeah. So quick launch update for people that have just tuned in. Hardware is fully integrated, so the gondola side is ready. Yeah, sure. So the gondola side is fully ready to launch. Now we are waiting for the fueling procedure to finish. You now can see basically Ferdi and Michi. These are the two people that are kneeling around the balloon. They are basically attaching the device that will allow the helium to flow inside the balloon. And once we have filled the balloon, we can attach the gondola at the time that the procedure describes, and then we can open the hangar doors and let the gondola fly. So that's the plan that we have. Our launch window goes...
Greetings to Benze. It's good to see you. Truly a legend when it comes to the past balloon launches. It's good to see that you're following us today.
So, do we have an update from...
Yeah, another little update is that fueling should start in a couple of minutes. Let's see how fast they are, but it should be around 3 minutes or so.
Awesome.
So we will see the balloon get bigger, and then we will, fuel it and see how it goes.
How are you going to
Great
get
to
that
hear.
hangar door open again?
Just push. Just push.
I was wondering if you've already introduced the most important person today, Hubertus.
Oh, true.
Yeah, but
Where is
that
he?
honor should be Philip's. I mean, he was the one.
True, yeah.
I
Philip
think
should.
right now,
Philip, do you want to grab all
Philip,
the
do you want to
favorite
introduce
mascots?
Hubertus to the people?
Oh yeah, absolutely.
Yeah, we got it. All right. Anything else you want to go
I
through?
think there's...
Do you do any knowledge? MSET, did you have anything to do with him? Because I certainly didn't so
I haven't
far.
had any contact with MSET. I mean, we as the WARR are part of the BVSR, which is the Bundesverband Studentischer Raumfahrt, in which the WARR is actually one of the founding members. And we were at the conference this summer, and so there we do have contact with other student groups. We also have contact outside, but yeah, I think.
That's a really good question, actually.
Yeah, maybe you want to. So a little explanation about that. This is our mascot. It was a gift to our former software team lead. And his name is Hubertus. It's a Blaha. And definitely a team favorite. There's pretty much nothing this team does without this shark around. Okay, we've got 2 more questions actually. Let's go through those. The tall metal thing, yeah, that's not the fueling system. That's basically the balloon gas we are going to use. It's its tank. So in a way, it is the fueling system, if you will. Although the system that is used for fueling is more or less covered at the moment by our launch crew. The tank itself contains balloon gas. It's basically
helium,
a mixture of helium and I think some nitrogen, just to stabilize.
We have a go for launch. Awesome to hear. So I think now they will start. I mean, look at Ben is our fueling guy. So the guy with the brown pants working on the gas cylinder. So he's now opening the gas cylinder, putting pressure on our filling device. That had a really technical name, to be honest. I'm just gonna call it filling device. It's the golden device with the two clocks on it. You can read off the pressure there, and based on the pressure, you can just put the appropriate amount of pressure into the balloon.
What's the material and how heavy the balloon is? The balloon, yeah, basically the material is a special kind of latex. It's like cross-stitched on its macrostructures to stretch in multiple directions without ripping. But other than that, it's pretty much
Pretty light. Like the thing that weighs is the gondola. It's, as far as I'm aware, 1.5 kilos, so also not that high of an amount, so it should be fine.
The balloon itself can carry up to 3 kilograms, if I remember correctly. We also have, I think, still a 5 kilogram balloon in reserve that we intend to use the next time around. But then there are, of course, larger stratospheric balloons, as for example used by Bexis, which are friendly Project Spicy.
We are getting the fueling done, I think.
Yeah, what you just heard was some noise coming from the helium tank.
Okay.
Yeah, it should be pretty old, so that might be the reason that it's starting to
Let's see what happens.
groan a little bit.
I mean, it seems like the balloon has a little bit of gas in it.
Yeah, I mean, he's now increasing the pressure. Like, there's two clocks, and I can read off. Like, the left clock is basically reading the pressure inside the gas tank, and the right clock is reading the pressure that we supply the balloon with. And I think he's slowly increasing that pressure now. That's the sound that you hear, I think.
You mentioned it the last time around, but man, you got good eyesight.
Yeah, I know. I mean, you are the one wearing the glasses.
Yeah,
and you can now see slowly I mean, you won't probably see it on your stream, but basically the right hand clock is measuring what the pressure is that we supply the balloon with, and it's, I think, as far as I can see, going up. It looks pretty good. The balloon is filling up now.
Yeah. As soon as it's nearing completion, I'll get ready to call the tower.
Yes.
So I see a lot of blah high love.
Hell yeah.
It's great to see the balloon filling up while I can just watch planes land on the right hand side. It's just awesome. Like, the location is just great.
Yeah. And I think we even have some luck regarding the weather.
Yeah.
Despite original forecasts saying that it's going to be a quite tough day for a launch, it's starting to clear up a little around. So, yeah, we should be good to go to launch within the next hour.
So, we are going pretty well. Do you want to say some words, like explain what's going on, maybe? Or,
Please.
I don't know.
like, just if you feel comfortable.
So yeah, okay, what you can see right now is the balloon filling up. Ben attached the pressure regulator to the helium bottle, and then you can see the little gray. You can probably see the little gray thingy. I'm looking if it's there. Yeah, but yeah. You can probably see the little gray thingy sticking into the balloon. That's where the helium comes through and then into the balloon. I don't exactly know why it's making this noise. It never has done so before. However, gas is coming out on the right end, so it should be fine.
Yeah. I mean, the balloon is filling up. The pressures. I can't really read them off, but the pressures look like the test runs. They look fine, to be honest. So yeah.
It's just the noise floor that's a bit elevated, so
it's part of the atmosphere.
We have another question. What's the prediction for flight duration?
We are expecting a 2.5 hour flight based on our simulations for the balloon. The recovery team is gonna basically just start driving off as soon as the balloon launches. and the location where I'm not going to disclose the location, but the location where the balloon is going to land, we will take with car like around 2.5. So we need to really be 2 hours. So we need to be really fast to be there before the balloon to detect it, basically. So yeah, I'm just gonna excuse myself. I just need to go.
Yeah, sure.
Yeah. So we're taking over the stream.
I don't exactly know what to tell you.
Hello.
Philip is back.
Nice.
So as you can see, fueling is on its way and it's looking great out here. The weather looks also way better than what it did this morning.
Yeah.
So
We had some spray rain this
Yeah.
morning, but it has cleared up and
Yeah, also the tarmac was. Yeah.
I grabbed to the other half of the balloon management.
okay, awesome.
You weren't yet in here. Wanna
So now you
Wanna
have
join
two
us?
Jakobs here.
Hi there. Okay, where's the PR team?
I think
I don't know.
we've taken over the stream.
Okay, so we're just going for it.
Yeah, we're gonna have to talk.
Okay, yeah. Okay, so basically, I don't know if you can hear it, but we're currently fueling the balloon. You can see it, certainly.
Yeah.
Yeah, so far, I think everything is going according to plan. Yeah,
How do the pressures look on the pressure regulator?
no worries about that.
Okay, great.
I would also really like to thank the two Jakobs because they really did a lot of really good work over the past semester and the past year. And without them, this wouldn't have been possible. So,
Thank you.
You make me blush.
Take away the microphone.
All right, wait, quick distraction. Thank you for the feedback regarding the valve. We just checked in. It's actually quite well opened and everything. Everything looks fine. It's pretty much only just a very old valve and a slightly larger pressure than the last time around, which leads to friction at one of the connectors. But there's no leak and everything looks just fine. Still, thank you for paying attention and giving good feedback. We absolutely adore all of the involvement today in the stream.
Yeah. All right, it's the first move stream since a while.
You can basically add this to one of the mission objectives today as well. Now that they're not here, we can, praise them to hell.
Oh yeah,
The R team
Let's
is
go.
an absolute amazing addition to the team.
They did such a great job.
They started all of this work like in this semester, and pretty much all of this, the stream, the entire setup was their own effort and their own work. And it's turned out quite amazing. And yeah, one of the main objectives of today is also to test out whether we can live stream events like this.
yeah, and that's maybe also something that I mentioned earlier. We have roles in a lot of different positions. Besides the technical ones, we obviously also have positions in PR, in management that are open to everyone that's interested. We always love it when we have people from different study programs coming together and working at a vision jointly. And so if you're studying at any of the universities in the Munich area, and you want to join us, contact us. We're mostly located in Garching, so you might have to drive out there, but it's always quite a lot of fun. So
Yeah, it is a lot of fun. We do like general meetings on Wednesdays where we not only do the meeting and then say goodbye, but most of the time we'll stay there till a bit later, and also like have dinner together and have events like this right now.
Okay.
Got one more addition to this stream.
Yeah.
Shen, formerly mentioned, he's pretty much responsible for the main payload today.
Yes.
He did the heavy lifting on everything, pretty much.
Up until the balloon does the heavy lifting. I'm sorry for that.
Maybe you have some questions for EPS lead, who is constructing not only the
Yeah,
batteries, solar cells, but everything else regarding the electrical power.
You want to take a seat?
I'm gonna. I can grab one.
Okay, he's gonna grab a seat. Until then, maybe the live stream is gonna be online.
Okay, we'll just check in.
Okay.
Yep. Now I've got the microphone again.
Okay, you see the balloon certainly lifting up.
Yeah. Okay, so
yeah.
please prepare your questions for Yichin.
Yeah, if you want to ask our chief electrical design lead or whatever positions are called now, just ask away.
Sure.
Okay, you see right now that they're stopping the filling. I don't know what's going on exactly.
I believe they're double checking the degree to which it is filled and that everything works correctly.
Yeah.
We don't want to over or underfill the balloon.
Okay, it's all right. Oh, it's lifting up.
Oh, yeah. Now you can see it's
Damn,
starting to lift
quite
up
big.
from.
I hope you get it out of the hangar door. That might have been my idea to fill it up in here instead of out there, but Friedrich told me it's fine.
I mean, I'm pretty sure we'll be able to get it out of the hangar door. There's still a lot of.
Okay, yeah. Yeah.
As you can see, very busy for all the
Anything
members
you
of
want
the
to tell
launch
us?
crew.
Anything you want to tell us about the battery boards, the electrical side of the balloon?
Yes. So I can quickly explain what we have as payload or on the whole system. So currently we are flying the battery board V2. That's the newly developed battery board in combination with our in-house developed EPS backplane V5 that is to be tested. So we already tested EPS V3 on the last balloon flight, and we have several improvements, including the CAN transceivers, which sadly didn't work this time. But we will. So basically, the V5 has numerous improvement over the V3, including its power capabilities, monitoring capabilities, and more. And the battery board V2 is also an upgrade from our previous iteration of battery boards. It can now balance the battery much better, and also records data like the remaining charge, the current that is being drawn from the battery or being charged, and also the temperature. It also includes a lot of protection features like under voltage, over current, over temperature, under temperature, and more. So it's a pretty nice system. And yes, the whole balloon is currently will be powered by the battery boards.
So maybe tell the chat which part of the data are you most excited about? What is there any specific value that you're really looking forward to getting the test data back on?
Yes, actually, for me, the most exciting will be the temperature data in conjunction with how the battery performs, because that's my main concern right now. Because especially LiPo batteries perform commonly not as well when you have a low temperature. So it will be amazing to see how it reacts in the lower atmosphere where it's really, really cold, up to minus 40 degrees. We did a test yesterday in our icebox, where we put the battery board for 1 hour and minus 80 degrees. It actually reached minus 20 degrees max, and it survived pretty nicely.
It was quite wet afterwards.
Yeah, that is also true, and it also can withstand that. So that is really good news for us.
I mean, you designed it to be pretty much
so
resistant,
ESD
resilient
yes.
to ESD.
Yes, it's also ESD safe, so you don't need a ESD band to touch it.
We just got a question. We just got some questions. So first, is there a Spezi crate underneath the balloon? What's the reason for that?
Well, the Spezi crate is there mainly for safety. It's holding down the balloon. You can. I mean, you can take it. We're outside. We would have hooks to anchor the balloon down. Inside here, we do have the Spezi crate, which is more than heavy enough to let's say keep the balloon on the ground.
Yeah, then I've got the perfect timing. Little launch update for everybody watching. We're currently fixing some issue with one of the cords leading to the counterweight, or in this case to the Spezi crate. But everything should be a-okay in a second. It's just taking a little more time to make sure that everything is nice and even. It is adjusted already. See, it's rather quick today.
Okay, and then the second question is everything powered by one source, or do you use different power sources for different parts of the payload?
So yes, so currently we have two main power sources on the gondola. The one that is mainly powering our whole system will be the battery boards. We will have two battery boards on the gondola, each providing 20 watt hour of power. And the second battery, it's a power bank. It provides the power to the camera system, like the Insta360 X2, and the engineering camera that we have on board.
Also our tracking system is redundant when it comes to its power source. We do have a separate flight proven already battery in there for the APRS tracker, and the Stratoflight's tracker also has its own integrated power supply, so we should be able to recover then. I think my AirTag also has an integrated battery. However, it's not rechargeable, but it's like this little cell.
Other trackers are available.
Huh?
Okay, any other questions?
If you want, I can just give an update on what was happening right now. Okay, so you might have seen that we stopped fueling for a second. That was because we used a way to check if the helium does its job and doesn't leak out anywhere. And for that, we need a connection between our water canister and the balloon itself. What happened before was that our safety wire was shorter than the wire between the canister and the balloon, and so we just adjusted that, and now I think the number on our weighing scale behind the crate should decrease.
Okay, good to know. I could check in with Vincent actually what the number currently is. Du Vincent, sag mal, was ist denn die Zahl auf der Scale gerade? Wie schwer ist der Wassercontainer noch? Wie schwer ist der Wassercontainer noch?
Okay.
Huh? How much again? Ah, nice.
Okay.
So we started with like
5.5 or something.
Huh? We started with like 5.5 or something. We're down to 5.1 right now. That number is gonna decrease until it hits 0, and then we'll stop the fueling, because then it's the balloon is full enough to lift our system.
Yeah. So Yichin just said that he will have to return to his other duties. So thank you very much for telling us about the payload. And yeah.
Oh, you've got the mic.
Oh yeah, I've got the mic. Yeah, I'm just gonna. So right now everything is going according to plan, I think.
Except for the noises.
Yeah, the noises are okay.
Yeah, the balloon is actually quite a lot bigger than I expected.
Yes.
I wasn't able to join the pre-flight tests, so.
I mean, it's the first time for us to see it as well. Our fueling test runs, we couldn't use any helium, so it wouldn't fly away. So this is the time that we see what we are working with. But looks good. I don't know.
Fine. We'll fit through the door.
Oh yeah.
It will not get much taller than it is right now.
Yeah.
So
we will
there will be no trouble.
We will have to take care of it outside, because it's a bit windy outside, and so we will have to be very careful when releasing it.
Okay, we have another question. Do you think do you use the weight of the water container to calculate the lift?
Sorry?
Do you use the weight of the water container to calculate the lift?
Yeah, exactly. So basically, there's a website where you can enter the ascent velocity you will use, the weight of your payload, etc. And from that you will get the so-called neck lift, which basically means how much lift force the balloon itself needs to do. to ascend the gondola with that amount of velocity. And in our case, it was 5.8 kilograms. And that we can just enter into with the water canister to check if everything is going to plan.
Okay. As you can see, fueling continues. The balloon already looks quite full. So.
Mm-hmm. Yeah, I think it will need a little bit more, but.
Yeah. Ask Vincent again.
Yeah, but I believe he's currently busy with the checklist. So.
I mean, did you already talk about the physics behind it? How it will work, and how it will come down again?
I mean, you can talk about that. I think.
Okay.
Maybe PR touched it. Maybe you touched that.
Hi, PR.
What did I touch?
Did you talk about how the balloon will inflate further and stuff?
Yes. I mean, I didn't talk about inflation further. I talked about basically the way we control the height with weather balloons is. Guess who's back? Back again.
Yeah.
So, yeah, I mean, it should be fine. Oder? Ach so, ja, stimmt.
No worries.
Oh, ja, okay.
Sorry.
So, yeah, basically the way we control height with weather balloons. The balloon that you see right there, that will not be recovered. That will burst. So basically, there's pressure inside of the balloon, inside of the basically the latex material, and the higher you go up in the atmosphere, pressure drops. The more it drops, the more it will inflate. At some point, the stress is too high for the material, so it pops. That's how you control basically altitude, and that's when it will come down. On the same rope, or is it a different rope where the parachute is attached?
No,
it's the same rope. Yeah, on the same rope, the parachute is attached. On the ascent, the parachute drag is negligible, so you can just leave it there. And once it pops, the parachute just slows it down and makes it so that the gondola stays intact.
Yeah.
So,
so just so you know, as you can see right now, I think the diameter is a little below 2 meters. When it rises further up, it expands, like Jayon just said. And at the highest point, it will have a diameter of like 12 meters or something.
Yes. You answer the question if the batteries are heated?
No,
I think they are not.
They are not heated.
They are not heated. I remember yesterday Yishan did some last touches on the testing, and he put it in the freezer.
He told us about that.
So no, for us, the batteries are not heated. We do have a battery heater for Move 3 that is already developed and tested, and it holds up to that. However, we're not going to fly it on here. We're just going to rely on our insulation.
By the way, I account the Strato space account said the noise is coming from like a valve. That is
okay.
I think they checked it already.
They checked it, so yeah. I mean, from our end, everything is running as expected. So
okay, perfect.
Yeah. Is this a leak? No, they're looking. No, it's fine.
They're cheering, so.
Yeah, they're cheering.
I'm gonna go check.
Yeah.
Launch director is going back to launch directing. Flight director, sorry.
I'm the launch director.
Oh, they are both Jakob, so.
Yeah. I do believe the gondola has quite some insulation.
Yeah, it's made out of styrofoam, so.
How do you
okay. So the canister is lifting right now.
Oh yes, let's go.
Oh my god.
Sorry for
Thank you for the headphone. Sorry for the headphone users.
Yeah. Okay, so it's sufficiently filled now.
Yeah. So how we get the payload back? Well, the recovery team goes and gets the balloon back.
Yeah, that's my job, huh?
Mine too. We'll have to head out quite soon after the launch.
Yeah, my phone. I would have wished to give you guys like a bit of a after launch experience. My phone is doing all of the streaming right now. So data.
So the hissing you hear is the or we hear at least is the proper filling of the balloon. They haven't stopped. It's now actually filling without a noise. Apparently the pressure in the bottle was too high in the beginning, and that's where the noise came from. Which is fair. We only tested with like lower pressure bottles. We're now at like 3.2 kilograms of remaining downfalls, I guess.
Okay, great. Yeah, coming back to recovery. So basically, my phone is doing all of the streaming. So I need the phone for recovery. So and I need to leave. Like, well, basically, recovery needs to leave very soon. So once the thing launches, we'll say our goodbyes, and I have to take the phone with me, and that's the end of our stream. We will keep you updated once we have it recovered. But yeah, depending on how that goes, yeah, just follow us on Instagram. So
Yeah,
that's
just plugging the account.
yeah, just plugging the account. Just so var.tum and var.move or var.move var.dot. So my English is.
Yeah, it's quite difficult with
Yeah.
the we have quite diverse amount of nationalities in our
Yeah.
team, and we
use the
constantly
GPS
switch it
tracker.
up between.
Yes, we do. So the tracking that we do is, I mean, let's start with the hopefully the one that we will not have to use is like the AirTag. So that's the last line of defense. We use a GPS tracker by Stratoflights. So basically, once the landing occurs, there's a GPS module in there, and then we can just use the app and a phone number to detect it. During flight, that's why we need to leave really quickly because the balloon might be a bit faster than we are. We use APRS to basically track the balloon. The balloon every time the balloon has a GNSS or like a GPS signal, it sends out APRS data that we are able to track with our antennas, and that's the way we basically try to retrieve it.
And one of the people who made all of this possible is now here with us.
Yeah, so I think I will head back to the fueling process.
Hi,
Have fun
my
stream.
name is Christian. I'm the operations designer of Move, and my job is to get the data visualized, which we get from our balloon in this case, and and that is what I'm doing. And with this data, we hope, or which you will also see later, we want to try to track our satellite down or cubes or our balloon down, that we get more and more data down also now live for you guys.
Quick question from the chat: have we ever lost a gondola? As far as I'm aware, no.
We haven't lost one. All of them turned up eventually. The keyword being eventually. There was one gondola that could not immediately be located due to a problem where the tracking at that time detached from the gondola. So the parachute was found, the gondola was not, but it was returned by the person on whose where it landed. So about 3 months after the launch, suddenly there was a call. It wasn't actually a call. I believe it was just sent back with the instructions on the gondola. So it just turned up, and there were still some lights on in the gondola. So that's actually quite impressive. So no, we haven't ever lost one.
But we took our time.
Yeah.
So hopefully we won't have to take our time and everything will run smoothly. As I said, just follow us on our social media channels. We will keep you updated there. If you do not post today, do not assume that we haven't found it. It might be that I just haven't come around to it. We'll basically eventually announce when we found it, and do not assume that when we do not post today, we haven't found it. So I might sleep. I'm kind of sleepy.
Yeah. There's also the possibilities that some of the designers might take it away right away to get some data of it. So
it might be taken away quite quickly. So hey, we have got Alex with us.
Yeah, I just wanted to say hi. Right now we're doing the fueling, and afterwards comes my task, which is gonna be regarding the parachute and holding it. Yeah.
Okay.
We just had a small silence.
It's a regular launch procedure. So basically, they check for any leaks, I guess, during that time. Just check if anything is hissing. So yeah, we need to be kind of stop yapping during that time. But I think the check went through, and they're continuing filling. So it seems everything is running as expected. It's awesome.
Yeah.
So
it should take another 9 minutes until fueling is done.
9 minutes until fueling is done.
9 more minutes.
Estimation. I don't know. Like this is like my first time around like launching balloons, and like I don't know what I expected, but it looks really cool. Like,
Yeah, I've been at one balloon launch, but it was a bit. I believe it was quite a bit smaller than the one we're
Okay.
currently launching. So the balloon was also quite a bit smaller.
So yeah, as you see, like the balloon that you see in this size right now, it's not going to remain at that size. It's going to grow and grow way bigger once it bursts at 36 kilometers and then makes it way back down on Earth, where we will hopefully collect it.
Yeah. Why the gloves? Maybe you can answer that.
So basically, at the beginning of the stream, we had a case where we had to not had to, but for safety margin did switch the balloons. So the material you see, it's a very sensitive material. It's basically a latex mesh material that that can basically expand more and more, and we want to be really, really careful with it. And the gloves are for that. Something very harmful for the balloon is basically also like all the oils that you have on there. So yeah, just keeping it away from that basically.
And I mean, especially if you end up opening up a balloon, deciding not to use it at that point, you could still use it at a later time, and then the opening and closing and the oils remaining on the material could damage it over time.
Could damage the balloon over time, yes. So there is some more fueling.
And check if I'm needed.
Yeah. Thank you.
Yeah,
Thank you for having me. Always feel free to ask more questions. But we are pretty close to launch, as far as I can see. The water canister that is behind the Spezikasten, that's basically a weight dummy. That's a weight dummy that is basically like appropriates the weight of the gondola, so we know once like how basically with the water canister we know when the balloon is appropriately filled, because that's the weight of the gondola. So how high is the balloon flying? 36 kilometers is the burst. So at that altitude, the weather balloon is designed and filled appropriately to basically pop, and from that altitude it's gonna fall back down.
I have a little update. We are currently examining a little failure in the helium tank. Again, since it's quite old, apparently one of the handles is somewhat broken and overestimated the contents. We still should be good to go to fill up the balloon sufficiently, but we are also currently tapping another source of helium just to be sure. So either way, we will launch.
Yeah. We have a bunch of... wir können ihn lesen, der Livestream-Chat ist aktuell.
Do you guys like cookies?
Yes, very much.
We do.
That's a Move internal joke that you will have to join us to understand.
Yeah.
Basically. Yeah.
Wir haben gerade die Antenne losgetragen.
So
we just put out one of our antennas that we will use to receive signal from the balloon. It will send down these beacons that we talked about earlier. And now we have it outside to receive once it starts. So things are going well, as you can see. Will take a bit of time, but we are launching.
Awesome. So Checklist has made an announcement in the... are we going to have data on velocity of the fall? Not live. We might have like the internal systems do keep. I don't know if they should log it. In the worst case, the 360. We also launch a 360-degree cam. That is that you will see the footage of once we have retrieved it.
I mean,
that has internal.
I believe Philip, as the person in charge of data here, can tell us. Will we get velocity of the fall data? Is that also something that's being logged?
That is something that is being logged. Yes.
I mean, also
we should get a path of like where we are going, how fast we are going, in which directions, and also. How high we are, so we will be able, and it also measures the velocity of how fast we are going.
And
down.
Also, we also know like with the weight and the specs of the parachute, what the descent is going to look like based on those data points. We also modeled the flight route basically, so we have a so-called Sollwert for the descent rate already.
Yeah, and we're seeing the first people starting to go outside, setting up some systems there.
I have a launch update for you guys. So we have now reached the threshold of which we can start a launch. We are aiming for a minimum ascent velocity of 5 meters per second, which we have surpassed. So now we are only filling it up a bit more to have a faster rate of ascent, so we are not that prone to winds changing our course of action. But we are now starting to prepare everything to transfer the balloon outside.
Du musst die aufmachen. Ja, klar. Die so herschieben, wenn da die Tür. Aber ich muss. Ich frag mal.
Yeah. Okay. So there's a bit of discussion going on for the for which of the doors of the hangar to open. So one of the doors is being closed a bit further because the balloon is situated right in the middle between the two doors. So by closing the one fully, we can then open the other one and get the best way for the balloon outside. And yes, we're tracking every move.
Thank you, Johannes.
Yeah, the puns are very.
Nice.
The puns are very strong. Also, thank you very much for the good wishes for the launch. I believe everyone is very excited. The launch crew is quite focused. So.
Yeah, and they are also now finishing up the gondola. We talked about it earlier. It was already basically ready to put everything in and to launch it. And now they are essentially closing the cover to make sure that things don't fall out where we fly. And that is going on right now. I think it should take around 15 minutes. They've been doing it for a couple of minutes now. So it will line up with when the balloon is fueled up, and then we can attach the gondola and then finally fly it. So stay tuned. We have a lot to do today. And it's already, the weather outside is also looking really cool. So.
So, what was your favorite part of the whole process of getting the balloon to launch?
I mean, the things I did the most for was about making sure the software actually works when we launch and that it sends down data. So we have this module on there that will send down data. It will. Oh, fueling is complete. We just got an update
that's
from our
awesome.
launch director. And okay, I think the other is launching. But essentially that allows us to get a couple of kilometers of live data coverage that we will also be able to show you on our dashboard. And so that's really, really cool.
Yeah.
So as you can see on your screen, we have this canister with water to counterbalance, and there's a scale to weigh how much the balloon is already pulling, so we can know how fast it can then go up with this amount of helium inside of it.
And in the background, it might be a bit hard to distinguish on the screen, but you can see the two guys finishing up the gondola, putting in some last screws to make sure everything is going on. Okay, so I mean, we have done balloon launches in the past. The idea for the project started around a year ago, so at the start of the last winter semester. Then we had first, obviously, the phase where we had to find people to work on the project, because even though we have a lot of people, most of them already have their tasks that they need to work on. And then the really hot phase started with the summer semester, where we then did a lot of the implementation and also some of the design for the tests. Originally, the launch was planned for July, but due to some weather problems and limitations with the open launch windows, we were not able to launch because it would have been too close to the start of the exam season. And we try to get our members to do some things for university as well. We try not to burden them too much during the exam phases. So we decided to postpone and be a bit more safe by doing the launch now after the exam phase and shortly before the beginning of the new semester. So yeah, it has pretty much been a year from start to finish, and it's looking really forward to
more launches.
Yeah, and also to seeing this one.
It's really cool to see the software now finally in flight and to see how it will go, to learn from it.
Thank you really much for the well wishes.
So I don't know, yeah, for anyone that's tuned in like right now, something really great about the project Move Up is I've started studying aerospace engineering more or less 1 year ago, and I've basically seen like a whole development cycle, and now I'm taking part of a whole launch procedure. So if you want to do something pretty quickly, in the sense that you can see like from end to finish how a development and launch cycle is, join Move, and especially Move Up, and work on really cool weather balloons, and also research, for example, interesting topics like microplastics in the upper atmosphere. Do we have a launch update?
No launch update from me. I just brought in our last guest for today. But Sophia, she was pretty much involved in the last 3 balloons, and she wouldn't miss it for a day. So yeah, basically we've got some Move history with us today as well.
Big shout out to Sophia.
She's joining the stream.
Oh, she's joining.
Yeah.
We're live streaming.
Hi, we're live streaming. So you need to go over here, and then you can join us.
We also have
Okay.
Join whenever you like.
Yeah. So you can say hi.
Hi everyone, it's Sophia.
Yeah, really exciting to have her here as someone who also was a big part of the last launches. So
first stage recovery. Yes, we are trying to recover the gondola, which is the golden part you can see on your screen. So they are currently putting it together for the final integration, and then it will be attached to the balloon and fly.
So,
and of course we then will go out and recover it.
So maybe a question for you, JJ. So once we transport the balloon outside, we'll have to open the hangar doors. Will the people on the stream be able to see the start of the?
Depending on how well I do my acrobatics, maybe. I thought about this. The idea is to basically hope that nothing falls off the table when I pick up the laptop and the camera and try to show you guys the launch. The thing is, you see the 2 hangar bay doors. I expect the launch team to open the further one. So, but the thing is, when they open, you cannot open both at the same time. On the right hand of us, there is an opening from the other side where I will kind of try to peek through with the camera. If you have seen the story, maybe you've seen the whole streaming setup, which is a bunch of cameras. So I will do my best, or we will do our best to try to give you guys a nice shot.
I mean, we can try to move the table over there.
Yes. But we will also make sure to post all the very cool footage we will definitely collect. We have multiple cameras set up around the hangar here. We have a 360 cam on the gondola, so we will get the entire flight also as a high resolution video that we will definitely post. So that's really, again, at this point, feel free to subscribe to our YouTube channel, or also follow us on our Instagram at WARR.tum or also WARR.move.
I mean, you can also follow the WARR on LinkedIn. We sometimes give updates there. But yeah.
On this occasion, also when you're talking about the WARR, quick shout out to the guys at Rocketry. Next week, EUROC is happening. Rocketry and Space Labs. Space Labs is the payload of the Rocketry rocket. Are launching in Portugal, and they will have their live stream as well. So tune in for that as well. Quite a power week for the WARR this the last few weeks, I guess. Space robotics or exploration. should be here around somewhere as well. Like they are doing the DLR Luna stuff with their team. We're doing our launch, rocketry and space apps have Europe going, so a bunch of stuff happening.
And I mean, we're keeping up the momentum definitely for the new semester. I believe Philip has already told you what stonks a bit.
Yeah, quite some time ago, so we can actually go over it again if you want to.
I would still keep the shot of the menus.
Oh yeah, that actually makes sense. Okay.
Yeah.
So Stonks is the student on CubeSat, student technology on CubeSat mission that we have done over the last year. It's been in collaboration with a Munich space company that allowed us to essentially put a self-developed circuit board onto one of their satellites. And what we will be able to do with that is that we will be able to test our newly developed sun sensors in space. So this is a really cool thing that we as students can essentially launch something into space that students have developed and try it out there. We have done a lot of testing. We will share a lot more about it when we know when the launch is. And yeah, so another reason to follow us on our social media. We will definitely tell you all about it when we know it.
So usually you would say the sky is the limit, but I do believe we're breaking that. So
next WARR hardware in space.
Yeah.
Yes.
Exact.
So
yeah, little launch update again. So currently we are closing in on finalizing the entire structure. We are nearing the launch. At the moment we are foreseeing it at 1:45, so exactly at the end of our launch window today. But everything seems to clear up. We made multiple redundant checks at this point to make sure that there will be no fault while launching. And yeah, it's so far we're good to go.
That's great.
yeah.
So what did you cover so far? We have Flyer Circuit, we had Move Up, we had Move 3.
Yeah, I don't know if you've talked. Oh, you already talked about Move 2 operations.
More about it, really.
yeah, now that we have
Yeah,
you here, that's
so Move 2 is the mission we currently have in orbit. First Move is also still on orbit, but there hasn't been any communications in a very long time. For Move 2, we are still in communication with the satellite. We're actively receiving data with our own ground station on the roof of the building in Garching. And yeah, the satellite is quite interesting as it is spinning, which is quite unique. But maybe you want to put some guesses in the chat how fast the satellite is spinning. Our high score. Maybe the Move members listening.
I know Quirin's username. I know Iggy's username.
Yeah, I know some of you guys are
definitely.
Are Move members, so that would be cheating if you answer. But maybe for the other ones,
just make a guess. Like what is a speed at which a satellite could spin, and you can still talk to it.
Yeah.
And also I think the most impressive thing about the spinning bit is like not only like the actual values, but being able to get it back down again. Actually, this was something really impressive that we have done, I think.
Yeah. So I believe since the stream is a bit delayed.
The stream is a lot delayed, actually.
Yeah.
Someone sent eyes.
Yeah. So.
Yes.
So since the stream is a bit delayed, we can continue to. Okay, so we got a 20. I'm not seeing any units though, which
is it at 20 degrees or?
Yeah, so we got a. I do believe that person's also a Move member though, because I recognize the profile picture.
Definitely.
So. Yeah, so maybe a little bit of what do you need for commanding a satellite if you join a student team? What we do is we have the members do their amateur radio license. Got something stuck in my throat. And then we do the technical trainings. What was the update?
We just got an update on the gondola, so our payload for the balloon that will be attached to it. and that it's ready. So we will be able to. So it's powered.
Degrees per
we
minute is
are
a really
getting
good guess.
data.
Not guess, but degrees per minute is exactly the.
So that is going well. One part of it is essentially done. So now we are waiting for the fueling to basically finish, and then we can attach the gondola. So it will take a bit more time, but stay with us. It will be very cool.
Yeah. So basically, for the mission controllers, when they join, they have their they do their technical training, which is basically a series of presentations by other members of the team. And then they do their amateur radio license. It's mostly self-study, but since in every batch a few of the people join mission control, they can study together. And then once they've done their license, they are able to do their practical trainings, where they do overpasses together with an experienced operator and start getting introduced to using the software one piece at a time, and then it finishes with basically a final overpass where they do everything by themselves but under supervision, and that's how you get. And this process usually takes between 3 and 6 months. So it is one of the teams with the longest training period. I believe in that time you can basically build a whole balloon and move up. But yeah, so we got we got a 20 degrees per minute. It's not our highest floor. Maybe try degrees per second. And then maybe try 680 degrees per second. This was the highest score, and also something that we're not actively trying to reach.
We got it back down again.
Yeah, we got it back down.
Okay. Launch update. The balloon is being untied of the water canister that you have seen. So now we are preparing to tie the balloon back onto, to the gondola basically. So at this point, once they untie it from the water canister, the only thing that keeps the balloon from hitting the roof is us.
So I hope someone holds it.
So yeah, have the fingers crossed. So yeah, right now we're slightly below 200 degrees per second, which is very fast, but it's still quite good for us. And
I think it's quite impressive that we can still communicate with it. Like when I joined and I heard about it, I was like, what? How is that even possible? And so yeah, I also think joining a mission control team is definitely something you can really go from being a normal student to being someone who operates a satellite that's in space right now.
And
so
I have to
really cool.
I have to say it's quite a flex to be able to talk to people and tell them that you've spoken to a satellite in the morning. So
and you can do it in between lectures as well. Like you can just leave, maybe even leave the lecture, and then talk to a satellite and then come back. Not something I condone, but basically we have a sun-synchronous orbit for our satellites, so it is above Garching right about the same time.
Yeah, and I mean there have been some changes to amateur radio law, so we're looking forward to possibly being able to do remote overpasses in the future, and that would be very nice. Then you could even do talk to a satellite from a lecture. Although we obviously tell people that they should listen to the lectures, so pay attention there.
Being in a mission control room is cooler anyway, to be honest.
Yes, I was in one for the first time, I think last week, and like it looks so cool, and yeah, so I would recommend.
And TUM actually has 2 mission control rooms, one in Ottobrunn as well. And with the changes to remote overpasses, we would be able to operate from there as well. So for all the aerospace students at TUM, that will be in Ottobrunn then in the future.
Update to the balloon. They are now applying. We have a thumbs up of our Friedrich. we have a thumbs from Friedrich. That is definitely on the launch procedure. But yeah, it's actually looking really, really good.
Yeah, and Alex is preparing the parachute on the side.
That's the red bit that you see.
And behind you can see one of the Jakobs and Yehin still working on the gondola. So
Yeah, it's
looking
coming along nicely.
Yeah. I mean, maybe you can also. Did you already tell the others about how training in your teams work? I mean, you also joined mission control, so that's a bit.
I mean, I'm a bit of a everything. Like I did mission control at the ADCS, move up, and now also a bit of PR. So
all of PR.
All of PR. So yeah, how does training look? Basically, you have a bunch of really smart people, really smart people around you that you can ask all of the questions you have. It doesn't really matter at what level.
Even about Kerbal Space Program.
Yeah.
Actually, especially about Kerbal Space Program. But yeah, I mean, you have so many talented people in the office, and just in I don't think WAR like attracts negative type of people. It's just like always really great and really helpful people, and you just talk to them a lot. They have, of course, they're like they have some procedures, some tutorials that you can do. Hello from the office and good luck. Thanks.
Oh,
hi, Bowen.
hi, Bowen. Yeah, one of the other fellow Move members. Maybe you can tell us if there's other people in the office watching with you.
Is there a watch party going
on?
Yeah, but basically you can just ask any type of question, and they are really helpful. And you learn the most by doing. Like I'm a third semester aerospace student. A third semester aerospace student, if they just do the stuff in the courses, they are not that proficient. You actually need to do stuff and learn the stuff to be proficient in it, and that's where student clubs play a big role.
Yeah. Oh, okay. It's just Bowen. Originally, we had planned for a bigger watch party. Since
like holiday season.
Yeah. Now with the
Also, it's not just you. It's not just Bowen. It's Bowen.
Yes. So yeah. So Philip, what's your experience with getting started in the team and your training?
So I started in the software team like 1.5 years ago, and essentially it starts out by just learning about how to work with hardware. Because what was new for me is that we are doing mostly embedded development. So we take, for example, these STM32 chips, and we program them and, for example, make them read out sensors, make them send data via like wireless modules and so on. And these are all things that you can maybe learn it from the internet, but it's really hard because like once you have a couple of things that don't work, you don't really know where to even start looking at. If you have experience with software, then usually making a software, making it work in a basic way usually goes pretty fast, but then making it work the way you want it to can be pretty hard. And with hardware so if you add hardware into the mix, it can be quite challenging. And that's why I'm really thankful that when I joined, a lot of people just helped me, essentially taught me how to do this, how to, for example, debug something on the chip so that when the chip receives a certain sensor value that you can see it on your laptop and then react to it and do things and understand why something doesn't work. So the software team is also pretty cool.
Quick update on the launch. We are now getting ready to tie the parachute to the balloon.
Are we flying the Spezikasten?
That is not part of the plan. The Spezikasten is there to secure the balloon. But yeah, you can now see how the parachute is being tied on.
So we are very close to the next steps.
Also, the helium bottle is being carted away.
That's great.
Everything is coming along nicely.
We still have a lot of time in our launch window, so given that they are now opening the doors, we
say hi, Ben.
Can expect to see a launch soon.
So yeah, we are now opening the hangar bay deals, and we are opening the cool one.
Should we turn the camera a bit?
Jakob, welchen öffnen wir eigentlich? Für den Ballon? Den da? Okay.
Okay, so good luck for everyone. It seems
die Gondel ist noch nicht dran. Ich würde es noch, also oder
ja, so ein bisschen mehr, je nachdem wie
yeah. So it seems like you will be able to see everything then.
Yeah. So ja, sure. Willst du echt ein bisschen ins Bild rutschen?
Okay.
So basically, the hangar bay door that is closer to you is the one that is going to be opened. And so I can give you a nice shot.
We have another visitor in the stream, Maxi, also one of our software members, and today one of the drivers for the recovery teams. So yeah, I'm looking forward to the road trip together with Maxi. We're going to be in one car.
Yes, it's going to be a lot of fun.
And yeah.
Yeah, basically now we are getting ready to tie everything on as planned.
Yeah, the preparation outside are continuing as well.
Yes. I mean, yeah, it seems fun.
Yeah.
It's ready.
Okay, the gondola will be attached.
Let's go. Okay, we are very, very close to a launch now.
Yeah.
It's being awesome to hear.
Okay, so not sure if you heard it, but the checklist has now moved on to the gondola preparation. So you can see it being wheeled over there. Maybe another question. So what is the silver item on the chair, which is also there in front?
So that's our radar deflector. So basically, airplanes need to be able to see us so they do not hit us. There's a lot of space up there, but just in case, if we should come anywhere close to them, their radar is able to pick us up. That's also especially if you're launching, basically if you're flying through a cloud, visual flight, visually you cannot detect the balloon. You can see it's a white balloon. So yeah, it's just there for airplanes to pick us up, basically.
Yeah. So safety is really the main focus.
Yeah. I mean, we get a launch permit from the regulatory bodies. We get a permit from the airport tower control. So yeah, everything is in check with those bodies that make sure that we do not endanger air traffic.
Yeah, and Friedrich will be the one to do some last calls right before we start, and then we'll get going.
From my view through the hangar bay doors, I can already see the ground station being ready to receive some data as well. They've set up a really nice control center there. Yeah.
Yeah, and then we'll have the mobile ones that we'll use for the recovery.
So yeah, I'm looking very forward to this and see how it goes. So the golden shiny thing behind the white shirt, that is our gondola.
Yeah,
so
I'm not sure you can actually see it at the moment. Oh yeah, you can see it a bit.
So that's our gondola. Weighs approximately 1.5 kilos. Carries backplane, battery boards, and other subsystem boards, together with a 360 cam that we will launch and then hopefully retrieve.
Are there any other questions about WARR, move, balloons? Maybe some of the people who just joined. I saw that we've
gained some viewers.
Yeah. And another one.
Gondolas. True, it's a gondola, not a gondola. True.
Yeah, but I believe the gondola was called gondolas in the past launch. This time it has a different name.
It's named Eagle. So basically, the way the gondola is built, I can actually use the proper ones that we have.
Oh, now we're getting the props for the stream.
Yes, we have the props. So this is a 3D printed, basically model of our gondola without the installation. So you must imagine that this has little spikes and styrofoam attached, and then basically over that there's a gold foil, which is our installation.
Why do you need installation?
Because up there it's really, really cold. How cold is it, Philip?
I think it was up to minus 50 degrees.
Yeah, up to minus 50 degrees that our hardware needs to withstand, especially the battery board. So that's why we need the installation. And the reason why we call our gondola Eagle, and that's Eagle with an E, is it has little spikes to attach the styrofoam. So yeah, that's a pretty cool thing, and I will say the Eagle has damage.
Okay, so for the other question, how's the weather here? So it is slightly cloudy.
It's a bit cloudy, but we've got permission from the regulatory bodies to launch with these clouds.
Yeah, so it rained a bit in the morning, but luckily it has cleared up. We can see a little bit of blue sky here and there. Oh,
launch update. Last cable is being attached. Last cable is currently being attached. So.
Okay, then for the next questions. I mean, I know you're already part of Move, but how do I join Move if I want to? If you want to join Move, there's multiple ways. You can either write us an email, but right now we have the kickoff season, so the best way would probably be to join the kickoff. One of our members has prepared a wonderful onboarding, which will be tested during this season, which hopefully means we don't miss as many people as we did last semester. There was a bit of a issue where we sent out a opinion poll and we did not collect the emails, but some people thought it was for sign up.
I mean,
the kickoff for Move is on the 24th of October at 6 p.m. in Garching in the Tentomax. And if you're not yet decided on Move, but rather want to join for the WARR, then that's the day before, the same day of the student club fair, the 23rd, also at 6 p.m. So yeah, that's the easiest way to join. If you're not ready to join yet and maybe want to join during the semester, you can just hop by our office or still write an email.
Every Wednesday, I think the date has changed. Like every Wednesday at 6, there's a general meeting that you can just drop by if you want and just talk to Lido Friedrich about joining.
Yeah. So what happens after the recovery? So once we've collected the balloon, we'll transport it to Garching. We'll probably at some point make a social media post announcement that we've found it, and then we will all get to the evaluation of the data that we've gathered, doing a documentation of what went well, what did not go so well.
We will reuse some hardware on there as well and retrieve the 360 cam footage that I'm really looking forward to, actually.
Yeah, me too. And then once all that's done, we're gonna prepare for the new missions, which will be happening next year.
Next year, and we'll be working on detecting basically microplastics in the upper atmosphere.
Which is a really interesting topic, especially regarding
basically our whole future. I mean, microplastic is a bit like the modern lead.
Yeah.
It shows up everywhere, and even in the upper atmosphere, which is crazy to think about.
Yeah. Okay. And then for the spelling of eagle, it's gonna be IGEL, so the German version of hedgehog.
I know it's Quirin, so I'm not gonna entertain it. I'm not gonna entertain it.
Yeah.
So yeah, we are looking pretty good.
Yeah.
So, there are some knots being done for the parachute.
Yeah, and they're attaching the radar deflector to the parachute and to the cable there. And yeah, we're still looking good.
So we have half an hour till the launch window closes, and we seem to be really good time.
Yeah. And checklists are still being checked.
And the lists. Checked. I'm here since I woke up at 6:30. I'm not used to it. So if I punt.
Yeah. So if you're if you're not happy with puns, then maybe we're not the team for you. We will have a lot of puns. There's something going on.
I mean, we keep on moving up.
Yes, the checklist is being completed as we speak. So
yeah. Knoten check, so means not check. Knots are being checked, so the knots are checked.
Yeah, that is really important because, as some of you might know, in a rope, if you knot it to something else, most of the time the knot is the weakest point in that connection. You will learn that in the mechanics courses.
I mean, I've done 2 and 3, I guess. Then.
Yeah, probably. I think they touched on it in our mechanics 1 course, but maybe they forgot it for you guys.
Yeah, might be. Or might. I mean, I passed mechanics once.
Yeah, that's important part. Passing your exams while also doing extremely fun stuff like balloon launches. But yeah, basically the knot is the weak. In most knots make make the ropes being connected weaker than if there were no knot. So checking them is really important to ensure that all the calculations that were being made are correct. And then
the knots need to be done in a special way so they do not have any friction to each other, so they don't. So they do not break apart.
Yeah, because if the knots break apart and we lose our parachute, that could be quite difficult.
Our flight director.
We So the stratospace account has told us that we should apply tape over all knots. Is that being planned?
I'm gonna tell them.
Yeah. So the helpful advice is being given to the team. So yeah. Okay. Still some discussions. Okay, Yichin is currently working on the gondola. The balloon is still being held by some of the fueling group. Okay, and there comes the tape. Yeah. Okay, so the knot check has been performed. I just got notice of that.
I just checked with our communication guy outside with the large antenna. He's also receiving all the data that we are planning on sending down during the launch. So that is going well as well.
Okay, I do believe I just heard a checklist gondola ready.
That's correct. So really stay with us now. We'll launch within the next...
within our launch window.
Yes.
So, yeah. And once again, for those that joined later, once the launch has happened, unfortunately, we will have to stop the stream quite abruptly because the
recovery team needs to
take
their phones with them.
Yeah, we need we're using one JJ's phone for the stream. So and he has to join us on the recovery process, and
we will keep him here until we can no longer see the balloon. So
yeah,
we will definitely make sure to bring you these images. And again, we will also post, for example, the footage from the 360 camera on our account. You will see a lot of the post-flight analysis, etc. on our social media accounts. So if you don't already do it, then follow us on our Instagram, which is WARR.move. And you can also follow the WARR.tum general account to stay updated on not just our team, but also the other teams that build rockets, microgravity experiments, and rovers. So it's basically all the cool space projects.
Yeah, and this is another reminder that on the same channel here on YouTube next week there will be another stream, this time from Portugal by Rocketry. With the Space Labs payload, so really a big WARR collaboration. It's always good to see all of the teams working together, and we'll definitely be cheering them on as well.
I love watching their streams. They are also very excited about the rockets.
So
They seem to be tying a couple of knots right now.
yeah, and they're okay. Some additional people are.
Working on the parachutes, it seems.
Yeah, there are
So we
some.
are about to open the door.
Yes, it's getting a bit hectic. Some people are looking for additional for additional gloves to securely hold the balloon in place. You can imagine something that's capable of flying to 36 kilometers in height is quite difficult to hold down. Yeah. I'm being called a TikToker. I I hope this stream is entertaining you, even though we haven't. Yeah, there are some comments from the out of the off, from the people prepared to open the hangar door, to let the balloon out once all the preparations are done. Um, some besides the preparations directly with the balloon, some discussions about the procedure are being done for the knowledge transfer of people that joined in the last balloon. Okay, so how many balloons do we usually launch per semester? So this is the first balloon in 2 years. We had quite a long break for balloon launches. But we are planning to increase the number of launches that we have. As I said, we're planning a bigger campaign next year, which will look at the microplastic in the upper atmosphere. And then, yeah. So we can't really say that we have a certain amount of balloons that we launch per semester, but we will increase the number. I'm just looking over there because I can see Friedrich on the phone. We'll just get the information whether we also get the approval to actually launch. Okay, so we're gonna get an update real soon. So let's
So
for the man of the hour, what's the update from the airport?
we've got a launch window confirmed for the next half hour. We have just a plane arriving at 14:40, and even in the case of a delayed launch, we are still allowed to launch after that. So as of now, we will launch in the next half hour. We'll just have to move the balloon outside, so the hangar doors will open, and then we'll transfer it to the outside courtyard to let it fly.
So will the gondola be attached inside, or will that be done outside?
It will be attached here on the inside. This is already underway. And yeah, we'll basically transfer the entire structure just outside to then launch.
Okay, that's awesome. So,
as you have seen right now, we have now 3 people holding the balloon. It might not be that visible from the stream, but it's actually somewhat daunting to keep it straight the entire time, since it just, tries to flop over on one of the ends or just destabilize due to the work being done on the downside of it.
I think the gondola is already attached.
The gondola is already attached. We are still securing the safety lines and checking all of the knots that have been done since then. The primary knot check has succeeded. And now, with that out of the way, I think we'll see the launch.
Is the parachute also already attached?
The parachute is already attached, yes.
Okay, so you can see the lines are quite long, but then again, if you go up to 36 kilometers, that's not really an issue. Yeah, I also already answered the questions about how many launches of balloons we usually have per semester. That we are currently increasing the amount we're planning. So really stay tuned and follow us and join us, especially.
Yeah. Anything else interesting coming up in the past hour?
We had a little guessing game about how fast Move 2 is spinning at its fastest, and I believe the guess was 20 degrees per minute, which is a bit off, but would be a really good guess for another satellite. And we explained where the eagle name of the gondola comes from.
Of course.
And yeah, we once again recap that we have our kickoffs and how to join us if you want to. And yeah, the 23rd is the general WARR one, as I said before. On the day of the student club fair, you will also be able to find us there. And then yeah, okay. So okay, there. The checklist guy Vincent, he has just talked with some of the people standing to the side. I think they are preparing to transfer the balloon outside. So
launch update, tapes are checked, the checks are taped. So like all tapes are checked, so we are pretty much preparing to launch.
yeah, it's really exciting.
The worst item still left on the checklist is just the transfer to the outside.
Yeah.
I mean, I think it was a good decision to do the fueling inside. I'm just sitting next to the open door, and it's already getting quite cold. So I believe the people sitting beneath the balloon, holding it for long times, they would get quite stiff. Yeah, the
Okay,
wind as
hangar
well.
doors are
Okay.
opening. Hangar doors are opening.
Great.
Okay, maybe move it.
The table. Let's move the table.
No, we need to for the yes.
Ja, deswegen move the
Yeah.
table so. Warte, ich mach. We are just.
Yeah, just quick. Okay. So hi.
Hi everyone.
Yeah, we just had to turn off the camera for a bit because the hangar door opened, and as we're on an active airport, we are only allowed to film certain things, and so to make sure that nothing that we're not supposed to film is in the image, we're.
Okay. I can describe to you guys.
True.
What's
We can
happening.
go to the other side and
Yeah, true.
do like a fancy
True.
like fancy reporters.
Yeah.
Okay.
So basically, I can just. It's out of the picture for you guys, but the balloon.
Yeah, if you do it fast.
So the balloon is being moved outside of the hangar bay doors. We have a bunch of people holding the balloon and making sure it is the right side up.
Okay, it's gonna be quite windy. If there's something in the chat. Okay.
Ich glaube, lass mal deins nehmen, das hat
Yeah. Yeah.
So the balloon is now fully outside the hangar and being carried outside.
It is quite windy though, so we're carefully.
They are really doing a really great job keeping the balloon upright.
And stable.
Yeah.
It's getting quite cold. I think you're in the
Yeah.
street. Yeah, so we
Glaub,
have a.
Severin,
another
ich glaube, da wo
camera
du vorher
guy.
standst, war es eigentlich ganz gut. Ja. Ich habe keine Handschuhe. Gib mal Hand, bitte.
This is us. And with us, thank you guys
Greetings
so much.
greetings to ViewSpace. Greetings.
Really, really cool.
Oh, be careful. It is quite windy. The wind has picked up quite a lot now. But we are carrying on with the launch. But the guys are doing a great job keeping it stable. We have prepared an area with cones for the launch pad. Können wir versuchen.
Dass wir keine Kabel zu weit ziehen.
Ja, das sollte gehen. Ich glaube, mehr als das sollten wir nicht machen. So ist gut.
Hast du das Mikrofon?
Ja. Lilu, ich glaube, das ist auf dem Tisch, das andere. Es hat aber keinen Hut.
Okay.
Okay, the guys are getting.
Wie kann ich den Dings hier machen?
The guys are getting ready now for the launch. We are now cutting away the saved lines. Okay, now from the carefully being placed on the ground.
Wie lange haben wir noch?
Okay.
Die Kamera können wir leider gerade nicht hochpennen. Ich habe das gerade nicht gecheckt, wie man es.
Du meinst das hier?
Ja. Ich habe versucht, aber die ist da so schief drauf. Also.
Boah, ist die Curse drauf, ja.
Wir müssen vielleicht so halt mit dem Teil heben.
Okay, but is released. Kannst du ein bisschen hochpennen?
Nee, leider nicht. Also außer ich nehme das gesamte Gestell.
Okay. Okay, now we are really close to launch. Balloon is only being held from the bottom. Okay, guys. It is going slowly. The red bit you see on the line is the parachute. The silver bit is the radar deflector. The balloon is now quite high up. There is some wind. I'll take over the cam now. There is some wind. Well, this is the balloon basically now. Sorry for the shaky cam footage. The tripod is not tripoding. I'll just kind of wing it. But yeah, We're seconds away from the launch now. Okay, cameras have been turned on. We have a 360 cam, we have an engineering cam on board. Okay, so basically there's one last line connecting the gondola to the Spezikasten. And once we cut that off, it's go time. So we're gonna slowly let the gondola hover. And once it's ready, we cut it off. So this is how the balloon looks right now. The wind is kinda picking up now, but we are still within launch conditions. Okay, the guys are getting ready to launch this thing now. Okay, now the gondola has taken off the ground and is hovering. The gondola is, I don't know if it's hovering or being, it's pretty much, it's hovering, okay. Okay, there's one lane connecting, line connecting the gondola to the Kasten still. It's now they're cutting the line. Now they're cutting the line.
10, 8, 7, 6, 5, 4, 3, 2, 1. Launch.
Launch. The balloon has been launched. Let's go. Balloon is away. It launched quite quickly. It moved like it straight moved over the hangar. I can't really get any footage. But yeah, this is our launch. Wait. Could show you this, but this is crazy. Like the balloon is up there. Yeah. Okay, now it is time for recovery. We are fighting against the time. It takes 2.5 hours for the balloon. We take 2 hours 10. Have a good time. Thank you for watching. I'll just quickly show you guys the kickoff stuff, and then just go. Scan this QR code. Come on. Scan this QR code. Join us. Do cool stuff like this, and see you next time.
Thank you, everyone.